I think the station is at 8 and a half. Yeah. J'ai réussi. Ah oui, j'ai vu, ils n'ont pas sorti les poubelles encore, j'espère qu'ils vont les sortir parce que sinon, parce que s'il y a un petit break et que les poubelles sont déjà faites. Ah oui, ouais, je l'ai testé. moi, si je peux dans une. Ah, j'arrive. Pour la route oui, oui, ça va me faire drôle. J'ai un peu de temps. Oui, mais je suis pas sûr que c'est bon. C'est toi qui en as un peu. Alors en fait, vous avez oublié de faire des scénars. Alors c'est là que j'ai pensé dedans. On peut les ouvrir un peu. Je vais tester ça. Et de toute façon, si je vais faire le coup de penser, je vais faire. Je vais tester.
Ha! This is great. This is perfect.
I hope. Yeah, it's perfect.
Yes, this is great.
Is it okay for you?
Yeah. This is perfect. And this is goes here to the.
I think yes.
Just let me see how that works. Here is large enough. Yeah,
So,
I think this is. Yeah.
is it okay or you want
No.
the sound is okay?
This is perfect.
Okay, perfect. A new version? Yes, of course. Just the switches.
T'as besoin d'un coup de main ou ça ira?
Ça va, on va juste uploader la nouvelle version. C'est bon. Tu sais pour la Tambourine, comment ça va se passer?
Non.
Il y a besoin de shell, du table?
Il y aura peut-être besoin de gel.
It's
normalement, sans une table.
It's a new one?
This one is you just need to leave the old one, please.
Je sais pas, normalement, quand on fait des tables, on met des chaises qui sont là, on les met autour. Je sais pas combien de personnes il y aura.
I don't know. Just, I don't know. Honestly, I don't know. So I'm just here for open the amphitheater and give some help, but I don't know if we have a laser pointer. Et on a un pointeur ou pas?
Comment?
Il y a des pointeurs ou pas?
Alors moi j'ai le mien. I can give you mine.
Yeah, this is great.
De toute façon, je le récupérerai à la fin parce que je le donne à la pour les sessions.
Ok. Bon, de toute façon, c'est le tien, donc...
This is both and normally...
Oh, wow. Okay,
Right.
Okay, so it's
Yeah, to switch on, switch off. Switch on, switch on. This is for the pointer, your laser. This is for switching the slide.
yeah.
Est-ce que tu veux tester, voir?
Good.
Perfect. Oh, yeah, we can.
Okay.
T'as plugué le
So
USB?
this is just to turn it on, so it's on, and now, and yeah.
Ok, parfait.
Why not?
Si, ça va.
Yeah, si, c'est bon, c'est bon.
Ah.
Perfect.
Wow.
Amazon, $50. the 30, not 50.
Is it okay? All set. Perfect. Great.
Attends, parce que moi je cherche le planning. Ah, il est là. Ouais.
So good to have you. Thanks for coming. Oh, from other videos. Yeah. You got the mic. Oh my gosh. If only all the speakers. Were you here for me? Make sure they find jobs. Oh yeah, all our Uber is so
our top choices. Almost immediately. I think it was one of the first ones. Yeah. That's right. That's right. Yeah. Yeah. So we tried really hard. There's still a couple that are online, but they're like all those are right here where you're trying to, if you interact. That's everyone gets the rules. Yeah. Big difference. It's his friends. It's friends. He's less friends. Yeah, that's right. Yeah. All those invited speakers get the bottom. Oh, so you'll get that. So you're you also came from already. Okay. Right. This is our comfort zone. Yes, I mean, very collaborative. Very, very low. So I'll work on the Python. Very similar. So advisor did my PhD with Stanford. So we worked on trying to sort of coverage of the body. Yeah. Midfield kind of focus on and that was 2 years inside the body. Since I've been doing some work on wearables, so we've been using like styles about pipe energy around the body, working on applications of mobile devices. So turn on LEDs, we can use them to treat cancer. So we actually like active drugs, for cancer. So we've done this with animals, like trying to get a company to put it into humans, but yeah, see if that works. It's very hard. Oh no, I'm at Singapore now, so I graduated there. Yes, yes, I graduated 7 years ago. I started in Singapore. Been there for quite some time now. It is. I enjoy the change of weather coming here. It is the same weather the whole year, and I've been stuck on that island for 2.5 years. Yeah, so here like I can comfortably wear long sleeve. The Bible is clear. Oh, for sure. Huge number of people. Sometimes we're pretty clean. Sometimes introduce your talk. Anything interesting I should mention? Okay, well, I'll mention that. I was talking to say that on Wednesday, we had to do space. Yes. John Rogers from Earth, and then you're going to be the last frontier, going down all the way down. So we really covered everything. We didn't plan your time. Yeah, it's perfect. It's perfect. Oh, yeah. Yes. Yeah, so actually, underwater, all these safety regulations we have, they don't make sense anymore. And how do you get to that? There's no, I don't know, sorry. There's no standards.
Well, that's of course. Questions whether you are or responding. It's better to anticipate movements, requests, desires, and act on it. The only one.
So you partner with
Hello?
So, my
Hi, Michael. Is the sound okay for you?
Oh, that's a really good question. Okay. You know, I'm only here. Simon's in all of them. It was not easy. I heard it on basically it's other than that, I felt
On peut les... Pas cela, il faut qu'on installe les chaises, mais vu qu'il y a la présentation, c'est un peu la merde.
Ah oui, 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 c'est vrai. Mais il faut pas le faire, il faut le faire après. Ah oui, il y en a un qui est rouge et un qui est bleu.
C'est normal?
À mon avis, ça va pas marcher s'il parle là-bas, mais j'espère que ça va pas marcher. Je pense que c'est
Tu as deux choses à faire. Démarrer un stream, et ensuite mettre les liens à jour dans la plateforme. Tu as le contenu. Regarde, c'est très simple. Quand tu veux démarrer et arrêter les streams, tu vas sur ce logiciel-là, la petite le rond OBS. Là. OBS, là par exemple, là tu es en streaming. Si tu appuies là, ça va arrêter le stream. Dès que tu arrêtes le stream, les liens... Ah oui, tu veux parler?
Juste, tout est bon de ce côté-là?
Tout est bon.
C'est en voie pour le streaming de ce soir. Il faut streamer ça, il faut streamer le panel aussi.
Oui, je vais partir, je vais apprendre à... On va essayer de faire par le mieux. Donc le streaming, c'est ce OBS là, donc tu fais arrêter et démarrer le streaming. Arrêter et démarrer le streaming. Attention, ça c'est juste un logiciel qui envoie les paquets à YouTube. Ensuite, YouTube doit renvoyer les paquets à tout le monde. Écoutez tous les deux. Donc regardez, pour YouTube, pour qu'il renvoie les paquets à tout le monde, on va dans son navigateur web. Là, j'ai le streaming, d'accord? Quand je suis en stream, du coup, là il est en streaming et on voit l'écran. Il est en stream depuis 44 minutes. Quand vous allez tuer OBS, ça va revenir noir. Donc là, vous n'êtes plus en streaming. Et YouTube ne redescend plus aucun paquet. Quand vous redémarrez un stream, attention, c'est un nouveau lien à chaque fois qui est généré.
Il faut mettre à jour le...
Voilà, donc il faut copier-coller le lien. Donc on clique ici, share. On copie-colle le lien YouTube, d'accord? Copier. Et ensuite, on va dans Où va. Et là, en fait, tu le mets sur toutes les sessions que tu veux. Par exemple, Unwired, Industry Exhibition. Donc, si tout ce qui est dans le grand amphi, tu fais Add Stream, par exemple, si je veux ajouter le stream. Add Live Stream. Et tu copies-colles ton lien. Tu fais Save et tous les gens sur l'application le verront instantanément. Ok.
On devrait s'en sortir.
Tu penses on refait.
Donc là, après le panel, on coupe le streamer.
Voilà.
Avant le prochain, on rouvre le stream.
On rouvre le streaming.
YouTube, on récupère.
On check sur YouTube qu'il resynchronise bien. Ça prend quelques secondes pour YouTube de resynchroniser son stream, machin. Là. Donc au début, quand tu stoppes le stream, ça va redevenir noir. Ça. Et donc quand tu vas redémarrer le stream, ça va réafficher l'écran.
Dès qu'on a l'écran, on fait share, on récupère l'adresse, on le met sur
Wova.
Sur Wova, on va chercher la bonne session.
Voilà. Vous avez tout ouvert, vous êtes tout admin, c'est mon compte. Donc vous fermerez juste à la fin.
C'est où qu'on close le stream?
Pour fermer le stream, tu peux le fermer directement dans OBS, donc arrêter le streaming. C'est ce que je fais moi. Ça arrête automatiquement celui de YouTube. Ou alors tu peux aussi l'arrêter de YouTube, mais attention, ça n'arrête pas OBS.
D'accord.
Donc soit tu penses à ça et tu arrêtes ça, soit tu arrêtes directement ça, boum, et ça l'arrêtera.
Mais on va faire ça.
Ok.
Et ensuite, on redémarrer le stream si on appuie.
Voilà, redémarrer le stream. Voilà. Il est déjà configuré.
OBS, on n'y touche pas, c'est juste arrêter de démarrer.
Oui, arrêter démarrer, c'est ça. Et vérifier que YouTube reçoit bien les paquets. Ok.
Ok, c'est parfait.
Vous êtes admin. Faites attention par contre, si vous explosez Wova ou YouTube, vous allez avoir des problèmes.
Parfait.
Vous essayez de m'appeler dans le cas.
Non, mais il n'y a aucune raison que ça.
Oui, voilà. Si vous faites gentiment,
il n'y a aucune raison. Il faut les mettre ici.
Faut les mettre où?
Bonjour à tous. Hello everyone. Thank you for being here. This is the last day of the conference, so there is not much to say. We have a couple of people that are interested in visiting Saint-Emilion tomorrow. So if you are one of them, you may just go to the registration desk and try to integrate a list, and then we'll see what we can arrange to go there. That's much everything. We are going to meet you at the end of the day with your class for photograph. So don't forget to bring everything, all of the time with you this afternoon. And that's it. Now adding the microphone to John.
I'm so thrilled to be able to introduce our last keynote speaker of this conference. We have here with us today Professor Johann Kohler as our plenary speaker. He is a full professor at ETH Zurich, where he directs the Power Electronic Systems Lab. Among at least half the audience here, the power electronic side, I don't think he needs any introduction. He is one of the most distinguished active researchers in the field today. His work has won over 40 prizes, which is just too many for me to read, but one of them is that he is an elected member of the US National Academy of Engineering, one of the very few foreign members. On Wednesday, we've had one of our keynote speakers talk about wireless power from space to Earth. Yesterday, we heard about power from the rooms into our bodies. And so I think it's only fitting to have Professor Kohler with us here today to talk about wireless charging of autonomously deployed deep-sea hydrogen.
So good morning. It's a very pleasure to be here, and all the stage is set up for the panel, so I will keep you entertaining this for the next 30, 40 minutes. Thank you very much for the nice introduction, and thank you very much for the invitation to give this presentation here. And as you can see here, it's the Lake of Zurich, and we are located in Zurich, Switzerland, so there is certainly not so much of the depths to explore in this lake, but we have been doing a project on the deep sea power transmission. It's a DC 3 kilovolt to 5 to 6 kilovolt DC transmission, and this is for a tethered ROV, remote operated underwater vehicle. And the next step would be to have this basically autonomous operating from the battery, which you of course need to recharge if it should be then emission unlimited, and if it should be permanently deployed in deep sea. Just to okay, since it doesn't nicely work, let me see how I can switch it. Get forward. Is it?
Because it's not on the PowerPoint.
Okay, so it also works here. Great. Okay, thank you very much. So just to show you a brief outline of my talk here, I would like to first introduce the blue economy to you. I mean, this is why we really need ROVs, AUVs in deep sea. Then I would like to talk about the ROV and AUV concept and the wireless charging, which is basically two systems. It's mid-core transformers or its resonant IPT, and then show you a built system, which actually is also on exhibition out there, and finally give you an outlook. What is the blue economy? If you think of the globe and the Earth's surface, you will find 70% covered with oceans, basically, or inland waters, and only 29% covered land. I think this shows the economic potential. And people say, and in literature you can read that 5% of this 70+% of surface covered with water is explored today. So this is an enormous potential and also an enormous economic potential. And if you think of renewable energy generation, you could think of offshore wind farms, floating PV power plants, offshore green hydrogen production, of course, from wind power, from solar power plants, or carbon capture and storage would be an option. Deep sea energy storage, this is very interesting concepts which I would like to briefly show you, and of course subsea industry related, for example, of course to oil and gas, but also to deep sea mining. And all this is infrastructures which are built or will be built in future in deep sea, and which need a certain inspection, need maintenance, maybe need repair, so all this requires finally robots. To show you a bit more of the detail, there is a report from the European Union, this Blue Economy report, and the definition is quite interesting and quite forward-looking. So it's economic sectors which are related to the exploitation, of course, oil, gas, all those others, but also preservation and regeneration of marine environment. So this is really capturing the full range and full perspective, and the established sectors today, of course, are marketing, transport, shipbuilding, fishing, offshore oil and gas, and coastal tourism. But there is emerging applications, and this is more the subject of the talk today. Here, the floating offshore wind and solar energy, wave and tidal energy, or deep sea robotics. And again, from the definition, I think this shows the Green Deal of the EU as a driving force also behind. Here, carbon, it should support the transition towards a carbon neutral circular economy, and biodiverse economy. So this is basically the background. And let's talk about first such application, which is offshore wind. And offshore could be in water depths lower than 60 meters or in larger depths. And then if it would be larger depths, it would be floating wind farms. And this is what we show here. You basically have three concepts. This is here the tension leg concept with cables which are anchored here at the seabed, and from a certain size of this platform, cables are just too expensive, and you would move towards a semi-submerged structure here, which is huge in dimensions. If you look it up on the internet, it's really incredibly large, because this is windmills of the 6 to 8 to 10 megawatt class. And you would have another concept, which is the spar buoy here, which is still under discussion because, from certain waves and storms, you could think that this has not a very well-defined position. I think the number here is interesting, that you would have 80% of offshore wind available in deep waters, meaning floating windmills. And they are easily higher and a more consistent wind speed, and of course we could say a lower environmental impact than if you build a wind farm on land. Another concept which is discussed and partly implemented, already implemented also in China, in a quite large scale, utility scale, is floating offshore solar plants. So what is predicted that a 10 times growth of solar power up to 5 terawatts is required in order to close the emission gap. I think this shows clearly the challenge. And what the driving force for going offshore or having utility scale projects on inland waters would be that you have densely populated areas and certainly a shortage of land. You could think of those centers like Singapore, for example, so there would not be much of the space to really accommodate PV on land. For this reason, we would like to maybe go for a circular-shaped little island here. A whole range of such islands has a buoyant ring around it, maybe make it flexible like a membrane, maybe make it rotate such that it's always oriented based to the sunshine. I think this is fascinating concept, but of course in offshore there's also certain challenges. Cleaning the PV panels is an issue. On the other hand, you have a lower temperature and a higher efficiency of the solar panels. And what is predicted and mentioned in studies that there is potentially a lower cost of offshore solar compared to offshore wind, and it should be a factor of 2. There is different studies which are done in this direction. And of course, people not just think of solar or wind, but also a combination of both, which from the energy generation over a day, wind might be still strong overnight, PV more towards the middle of the day, and this could be a very interesting combination, utilizing basically the same floating structure, which then needs to be inspected, maintained, repaired. What is the relation to our needs, and finally the wireless charging. If you generate a lot of power offshore, the question is, of course, how to really transmit it to the load centers. And one could say, okay, this is an established concept, it's a high voltage DC transmission, several hundred kilovolts of DC, even plus minus 800 kilovolts DC like in China, and then you transmit it to the shore. But people think of different concepts, and this is a little bit also related to the repurposing of pipelines from the oil and gas industry, which might be decommissioned in future, and then you could think of really transporting molecules instead of having electrons running over high voltage DC transmission lines basically. So this is something which avoids the high costs of the high voltage DC cables and the high voltage DC system here. And it's also interesting that if you would use platforms which have been used in the oil and gas industry, you could generate these water electrolyzers on offshore platforms such as green hydrogen. And you could think of, instead of linking countries through high voltage DC transmission lines, you could link them through pipelines, having energy hubs sitting in the middle in between different neighboring countries offshore, and then have a hydrogen pipeline running towards those different countries. Another concept, and honestly I did not know much about it before preparing this talk, but this is really interesting that you would say, okay, I can use electrolyzers, I can generate hydrogen, I can link countries through pipelines and high voltage DC transmission lines, and maybe a hybrid of both. But maybe it also would be nice to really store energy locally, store it offshore, store it deep sea, and then come across a concept which is pump hydro storage in deep sea. You might wonder what that should be, because you would relate it to a dam up in the mountains, you pump up water, and then from the water flow down, it would generate electricity. But there is something similar which people are thinking about. You see, this is those spheres here, and if you would think of sitting in a submarine, to open the hatch, there would be a huge inflow of water which you could use in a turbine in order to generate electricity. And if you would like to store, you would pump the water out again. So this is how this works, and this could be sitting on a 400 to 800 meter depth here, and it would be a really relatively simple mechanical plus turbines and electricity concept. So this is something which people are discussing for offshore installations, and would like to accommodate near wind farms, solar farms, or even tidal and wave energy systems. Another concept, and again, deep sea infrastructure and robots for the inspection. The decommissioned oil and gas platforms in future could be used, and to have all the pipeline infrastructure to really pump CO2 into some deep sea geological formation. And there is actually the world's first, as it is framed, offshore carbon capture and storage plant in operation since 1996 in the slide number 3. The reason behind this being that the natural gas there contained quite a large percentage of CO2, which needed to be re-injected into this formation here, because Norway introduced a tax, CO2 tax in 1991 in order to reduce it in 1991 to reduce the footprint of the oil and gas industry, and for this reason it has been economic to inject the CO2 again into this geological formation. And then there is a huge next area, which is deep sea industry. I mean, if you need to maintain a platform like you have seen on my last slide, and all the pipes down to the seabed, you would say, I want to get rid of this platform. I would like to get rid of the crew, which is extremely expensive to keep on this platform. I would like to have my whole industry, my whole operation on the seabed, located on the seabed, even down to 4,000 or 6,000 meters, 3,000, 3,700 is more or less the average depth. This is what people are thinking about. So we will think about deep sea oil and gas extraction and processing, and you will have no platforms, no crewed ships, no manned platforms, and you could also think of doing deep sea mining. I just showed you some example afterwards. And It's related to oil and gas, but especially to gas, because of the lower footprint, CO2 footprint of gas as compared to oil. And people in oil and gas industry are talking about the golden age of gas. So it's not something to stop immediately, and also because of all the issues we have in Europe now. But this is really something which is going to come. Large companies, IBP, GE, others are preparing, are already having certain infrastructure or components in place. And you can see, and this is taken from the brochure from ABB, for example, DC transmission over 600 kilometers, 100 megawatts of power you can transfer down to 3,000 meters, pumps, compressors, etc. You would locate them on the seabed. And the hydraulic valves are replaced by electric valves, which are higher efficiency and again reduce the carbon footprint of this industry. And just to show you two more examples for really burying the pipelines in the seabed, you would need to have a certain device. And this device is not something which would easily fit in the sand pit. It's really huge, as you can see on the next slide, and it's the burial of subsea pipelines and cables and such trenches which are doing a jet trenching. You have compressed water which is even cutting through rocks, and it's really the deep trench, 1 or 2 meter wide trench, and burying the pipeline. You can see also the power level here, and just to show you how this really looks in practice, this is such a vehicle like this, and just look at the number here. It's designed for several thousand meter operation depths, and if you have it down there, we would like to know about the condition, we would like to have an ROV really doing a certain inspection in order to know that all is going to work out well. And this is the last one which I would like to show you related to deep sea industry, which is deep sea mining. And you might ask, okay, what is the motivation here? And the motivation is basically something like what is shown here. It's so-called polymetallic nodules, which are containing manganese, copper, cobalt, and what you could find on the 4,000 to 6,000 meter depth. And we would like to have a vehicle here, and please note what I wrote down here. There is a real discussion whether this should be really implemented, because there could be a potential threat to the global oceans. You would suck in those nodules here, you would crush them, pump them out to this surface and supporting vessel. And just to give you again an impression how something like this would look like, it's a huge vacuum cleaner, you would say, which would not just suck in the nodules, but any other species which are around there. And you can see here it's a 25-ton robot, which has been tested according to literature at 4,500 meter sea depth. And now we mentioned it already several times, you would need, in order to inspect such infrastructure, you would need ROVs, remotely operated vehicles, robots basically, and you would like, and you would find quite some complex and inaccessible subsea infrastructure for all those applications which I have shown to you, and you would like to do INR, as it is called, inspection, maintenance, and repair. And this should be in an ocean depth of something like 2,500 or even 3 or even over 3,000 meters. And just to give you a little bit of an impression about the different zones you will find in the ocean, there's altogether 5 different zones. The deepest spot here being called is the Challenger Deep. It's 11 kilometers deep. So this would be Mount Everest here, coming down from surface. Whales are able to go down 1,000 meters, basically at maximum. And you would like to go down to something like 4,000 to 6,000 meters to this ocean basin, or the abyss, as it is called. And of course, you could not just do oil and gas or deep sea mining there, but you could also do scientific exploration and have seriously submarine volcanoes or hydrothermal vents and so forth. So now I think we have the reasons why. Why would we need ROVs for autonomous underwater vehicles, and how would we manage to use the power supply of such vehicles? And here you can see a categorization of such underwater vehicles. Manned vehicles would be one option, but what we would like to talk about is unmanned vehicles, and there is more. AUVs, like autonomous underwater vehicles, which is basically the way to go, a main way to go in future, or ROVs, remotely operated underwater vehicles. You have different classes, different categories, depending on the power level of such vehicle. And if you would like to do really just inspection, it might be a few kilowatts, which you might need for this vehicle, or even lower power. But for this intervention class of vehicle, which is light or heavy work class ROVs, you would need something like 10, 20, 50, even 100 kilowatts of power. And just to give you an impression about the economic value here, the global annual ROV market is, has been calculated to be $3.5 billion in US dollars in 2020, and this is the interesting figure here, and the 10+ growth rate over the next 5 years, and the AUV demand in 2022 showed a 24% increase as compared to 2021. Just to give you an impression, I mean, this is this ROV here, and it would be lowered into the sea from the surface and supporting vessel here. And this is a crude ship, and the calculation of the costs of such ship is $10,000 to $20,000 to $30,000 a day. And for this reason, I mean, this is a very nice concept. It's an umbilical here, which is lowered than this vehicle into the sea, and you can bring it down to 6 kilometers in depth. And this is basically a very nice concept. You can also see here manipulators. You have certain thrusters around the vehicle. I should show you this. And this is really a monster. It's not something which fits in a pocket. It's 2 meters long, 1.5 meters wide, 1.5 meters tall. So it's a huge vehicle. With the manipulators here, which are partly electric or hydraulic. You can see the dimensions here. It weighs on land something like 2 tons, and it's a 75 kVA power rating. And there is the ship and there is the pad, but we would like to have a higher level of autonomy, because if you lower the vehicle from this surface and supporting vessel, if you lower it into the sea, you would have maybe a launcher and then a tether, but you can see here the 250 meters radius which you would have. And this is just not sufficient, and if it's a very delicate structure you need to inspect, also the tether might not be the best thing to have. So for this reason, we really would like to go autonomous. And I mentioned before the medium voltage supply. You can find AC supply here, which however is an issue with the reactive power, which you need to bring into the cable because of the large capacitance per length. And for this reason, we would like in future to go for a DC supply, but still, whether AC or DC, this umbilical and the tether is something which you would like to eliminate in future, at least for lower power vehicles and inspection class vehicles. And this is how something like this could look like, and this is what we are arguing and why we are discussing the wireless power transfer. Because you would not like to recover this battery power, and you don't see any tether here. So this inspection class is running here, which is a is a trademark hydron, so it's underwater drone basically. So it would be operated from an onboard battery, but of course the battery capacity would limit the range you could have. People are talking about 50 kilometer, even up to 50 kilometer range, and this you would not like to recover the vehicle and bring it into the sea again, because you would need to have this surface vehicle, but you would like to get rid of this and you would like to have a subsea residency of such vehicle. And what would that require? It requires battery recharge, it requires data offload and mission download data, so the data transfer, and it might require power supply for the charging station from the shore, or you would like to locally generate this power or energy which you finally comes into the battery. So this is the idea here why we are talking about wireless power transfer about such vehicle. And now, if you think of this wireless charging, there is certain challenges which I would like to briefly highlight, show you two basic concepts which have been proposed, and show you one industrial system which, as I mentioned, is also exhibited here at the conference. Now, this provides you a little bit of an idea. Maybe you can see this subsea industry infrastructure here, and here is inspection drones, and there is those cones where they will dock and be recharged. Here is AUV in this docking station, which is funnel shaped here, because there is different challenges. So one challenge is that you have seawater conductivity. So it's not like air, there is a 3 to 6 meter Siemens per meter conductivity. It's not too much, but it restricts a bit the operating frequency which you could have, because you would generate air current losses at higher frequency. And there is water currents and turbulences and biofouling. I just showed you an example in one of the next slides. So there is a potential dynamic misalignment in a larger area. Not too much different wireless charging of EV, but from the medium there is a certain stability which poses a certain challenge. And you can see there is basically two concepts. One is shown here. This is this funnel type of docking station, or a landing on base, like landing an aircraft docking station, where you then would recharge the vehicle once it's sitting on the charging dock. And it should, of course, be done wireless. So people discuss about conductive charging, even in deep sea, but it's not very reliable. And for this reason, we would like to do it without a direct electrical connection, and the natural way to go is inductive power transfer. You can see here an image from the US Navy. They are, of course, also thinking of such ships more for surveillance and, of course, also inspection. You could see here this charging pad also attached to the submarine here. And you would like, as I mentioned, to get rid of those wet-mate, as they are called, connectors, and get rid of the direct electric contact and replace it with a split core transformer, for example. The advantage of such concept, and you can see an image here taken from literature, would be that you can confine the magnetic field here. Because you need to think that this AOD hull would be made of aluminium or of some conductive material, which would generate in addition also air current losses. So confining the magnetic field in a structure which is kind of a split core transformer, I think this is, of course, a nice thing, one of the basic concepts of the two concepts which have been proposed. And there is a certain sensitivity to misalignment. I think there could be a certain eccentricity that you will not manage to really bring the two parts very nicely together. And people are discussing about, and you see the high ambient pressure and in 6,000 meters is 600 bar. And there is a piezo-magnetic effect of error. So for this reason, there is a lower permeability. And this makes a certain influence, but still there is a pretty high relative permeability. It's reduced maybe a factor of 2, but still high enough in order to confine the magnetic field nicely. So this is not too much of an issue here. And what we could see as an issue is that if you have such a structure, there is really a matching needed between primary and secondary. You would say, okay, so what? I design it like this, but in future you might have a more open system such that different types and shapes and makes of vehicles can be recharged with the same charging path. So for this reason, this gives a certain restriction concerning interoperability. Just to show you, again from literature, such concept, and you can see here the secondary part. This would be on the ship which is docking. This is the primary part here, and you can see guiding leaves here in certain places. Flexible flaps. And the efficiency which you could embrace a certain air gap which is left here, which is just a couple of millimeters, however, and this system has been operated at something close to 100 kilohertz, has been operated at a 40 megapascal or 4,000 meter water pressure, and the efficiency which you could achieve is something here of 87%, assuming already a certain misalignment, a 5 millimeters of eccentricity of a 5 centimeter core, which was transferring 400 watts. So it's a pretty compact structure, but again, mentioned certain limitations concerning interoperability. There's a second concept, and it's interesting that I think there is a presentation from Panasonic, which goes in the same direction, but let me just introduce at this conference, but let me just introduce this concept first. So this would be more of this resonant IPT type. You can see here this funnel type structure. You would have an entry cone and then a docking tube where you would bring in the vehicle, and then you would have 2 coaxial coils, one sitting on the vehicle, the other one on the docking station, and you would have certain ferrite elements in order again to confine the field and not let it penetrate into the metal hull of the AOD. And this is how something like this could look like. You can see the transmitting coil here, the receiving coil. Of course, this needs to be adapted to the diameter of the AOD. Again, a certain limitation in interoperability, but other than this, a very nice concept. And you would have a certain higher tolerance to misalignment, which could be axial and radial, and a certain here you can see the structure. This would be the transmitter coil, this would be the receiver coil, and you can see actually this one should be sitting inside here, which from the dimensions is not very clear, but I directly took those drawings from literature. You can see the ferrite elements outside here and inside here in order for the field not to penetrate into the metal structure of the AUV. And once you would bring this from air into salt water, so then you can see that the quality factor of the coils basically reduces by a factor of 2, and what you could have as an efficiency here is something like 92% for transferring kilowatts of power, and you would need to imagine this to be A4 in cross-section. So an A4 page in cross-section, just to relate it to size, because efficiency and size is of course related. Biofouling. You would say, okay, this looks very clean, but you have seen on the last slides very nice technical drawings, but if you would immerse this into the sea, and this was a test 45 days in the same usual way, And this is what you then will find. You could have an anti-foul painting, copper-based anti-foul painting, and you could maybe also heat this structure on purpose in order to kill off any microorganisms. But this is a certain challenge. Of course, it might be different in deep sea, but still, this is what you could easily relate to misalignment as a very general term. Now, an industrial system which has been built over the last years, and just to show you this system, how it looks like, it's this landing on base, and this is the charging base here. It's built by Unplugged, they have an exhibition out there, and they are aiming to design a universal open standard docking station. And this relates also to data transmission. It's not just the power transfer. And they could show that they can transfer 2.5 kilowatts at 95% efficiency, and this is qualified for 3,000 meter operation tests and 15 years of lifetime. So this gives an idea, I think, what an efficiency, what efficiency you could achieve. It's not so different to wireless charging of EV. This is of this split core, more of this split core transformer type of system, but still it has very nice interoperability because it can land different vehicles on this platform as is shown here. So this is compatible with different type of vehicles. Here you can see also the efficiency curve, which is pretty flat, starting from something like 20% of rated power. And it's interesting also to land the vehicle and to position it correctly. Of course, we have a navigation system, there is sonar, we have certain other wireless communication system there. But for this homing of the vehicle on the base, there is this primary cybernetic field, which is activated and which is detected by the vehicle, and then the vehicle positions itself on this charging base such that the misalignment is minimized and the efficiency of the power transfer is maximized. So we talked about power transfer, data offload or upload, and of course still the question is remaining how to change the power for the charging. First is for this charging station, which could be a cable, a high voltage DC cable that is supplied from shore, or you would generate it locally. Just to give you an idea about such local power generation, and this is under discussion, you could see here the charging station, you can see the IOV here, the oil well which is inspected, and you could run a cable from the shore, or you could generate it on surface and also use then this surface structure for communicating data to a satellite and maybe to the shore. So this is what people are thinking about, and this is as much under discussion than this subsea charging station. You could have a wave energy generation here, or you would have so-called power audio, which is moving, a linear generator which is moving up and down. You are harnessing wave energy basically, and you could also have a certain battery storage sitting in this buoy or in the charging dock in subsea. This would be liquid polymer batteries, for example, in subsea because of this high pressure environment. And again, concerning high pressure, you would need certain power electronics in order to generate the voltage which is applied finally to the primary and secondary coils. Sorry. And there is two concepts, and one is a 1 atmosphere housing, which would have the same conditions inside as we have here in our typical environment, or there would be a pressure balanced housing where all the components here would be basically at the same pressure level than outside, which would mean 400 or 600 bar. And this has been tested, and there is ongoing discussions up to 300 bar. For example, isolated gate bipolar transistors, the switching behavior has been shown to be unaffected, but the silicon chain, which you typically have in such power modules, need to be replaced with a certain different cover, which should be free of any voids, which would immediately implode because of this very high pressure. And a brief outlook. Transformers. So this is one of the interesting concepts which is discussed. We discussed about AUE, but if you have an AUE, you can wirelessly charge it, but it would be nice to have an AUE which can transform its structure such that it could be more of a submarine type or more of this ROV type with certain manipulators. And this is something which is built here and which is semi-autonomous and which, because of this submarine and very nice hydrodynamic shape, can travel higher speed with lower energy consumption and will have a higher mission radius. This is one of the really nice concepts you can find. Another one is the E-Loom, which is a modular E-type concept with thruster, joint, sensor, payload modules, which you can fit together depending on the mission you need to perform, which you can stretch out, maybe have a torpedo-shaped AOE, or then you can kind of fold it together and have a two-arm robot which can perform certain repair tasks. So this is a very nice concept which you can find in literature, and if you have time, just visit this homepage and look at the video where those EVs are sitting in a subsea garage and then doing some maintenance tasks. It's really very fancy and nice to look at. And ultimately, the grandson of Jacques Cousteau proposed this, and the idea starts for this reason. I need to end this outlook like this. He has a vision of an underwater version of the International Space Station. So it's an underwater and it could help to discover new species of marine life. Aquaculture is a huge topic for future and a $1 billion business, as it is mentioned, and also understanding the climate change effects. This would be the ultimate goal for having such subsea habitat, which again needs to be supported by robots, AUVs most likely, and this is then the last slide I would like to show you, and thank you very much for your attention.
Thank you, Professor Fuller, for that remarkable talk. I think we're happy to take questions.
Hello, very good morning. My name is Dinesh. I'm the lead industry analyst on wireless power. First of all, very good presentation. Thank you very much. I can just start to say that WAL is a very good smart engineering product out there, subsea water, wireless power solutions. My question is, we have seen so many other products, applications in the market who are adopting wireless power, but many of these solutions are stuck in the development stages because of fall detections, water, grease, and all that stuff. And you all have very nicely, address that issue and define. So the question is, what is your reaction when you see these companies still trying to find a solution for something as basic like what you guys have said? Any learnings for some companies or message for them? That would be great.
I think if I may summarize the question as far as I understood, I think the basic concept which is used for this wireless charging is known and is similar to what has been used so far as for EV charging, for example.
I think you are perfectly right that in electricity, for example, submersed a EV charger into salt water and showed that it works at a certain level of efficiency, which was not very high, but 85+%. I think it's the combination maybe of requirements which you have, like this honing of the battery. It's not just the power transfer, it's also this how you can relate it to this energy generation, I think, and the power and the data transfer. I think this is, it's not, if you look at the individual system, you will say, okay, it's a state core transformer, and the image I showed you is from 2010, actually, but this is very comprehensive analysis, and for this reason I selected it. If you look around the literature, you find experimental data. You don't know has this been measured as in salt water, or in fresh water, or in the air. It's very scattered data, and not really very comprehensive and well-done technical analysis, and always just focusing on one single aspect. No data transfer, no question how the power is really brought to the charging station, which might be influencing the power electronics, and also on the whole size of this charging pump. And this is, I think, what is maybe missing round of the knowledge which scattered we already have, but it needs to be brought together finally into an industrial solution.
Thank you.
Thank you very much, Professor. I have a quick question. Suppose you are doing a transmitting platform to talking. Should not be efficient that you are doing the transmitting and then using a wire, then the wireless power transfer, because the main idea is to transfer the power from very far distance and then doing it at a docking system. But when the system is still coming very near to the receiving system, could not you use wire to be very efficient than the wireless power transfer?
If I understand correctly, I mean, you mean you could use a bed?
Yeah, basically you are transmitting is very near to the docking system, just add a wire and you shorten the wire. Yeah, you don't use wireless power, but because the concept is.
I think there is a discussion in literature on this. The reason is that for the positioning you would need to have in order to really plug it in. This would be more precise, need to be far more precise than if you just position two core halves, for example. Still, there is a large tolerance which is allowed, and also the forces which could act on such connector are significantly larger because there might be ocean currents, and the vehicle, is not just like a car sitting on the ground and recharge, but it's really something which is moving all over the place, and those connectors are mentioned to have a lifetime. You can plug them 100 or a maximum of 1,000 times together, and that's it. So this is really specified lifetime of such battery connectors. And if you think this is 6,000 meters below surface, and you need to recover it and install a new connector, this is the reason.
We have time for one more question.
Yeah, this is a good question. Yeah, thanks for that exciting talk. I have a question on the EMC and safety large ones. We call it undersea warranty. What's the difference?
Yeah,
what's the key difference?
The question is concerning EMC in this subsea environment. I can only guess, to be honest. I think what is mentioned basically, and what we would find is that you would aim for a core structure which is keeping the magnetic field of the magnetic hull of the AUV. So such that from like the coaxial structure which you have seen, either the core halves where you have the field combined, or the coaxial structure where you have the field outside, and the receiver coil and the transmitter coil, but basically the field is confined in between those two coils, but not inside the receiver coil. And there is the metal hull of the AUV, we should generate eddy currents and then shield off, especially at the frequencies of 100 kilohertz, any field inside the vehicle. So for this reason, I would not think that the light would be too much.
About safety.
Safety?
Normally, we don't have people there. We don't have people there.
There is no people down.
If it's autonomous, but my question is really about undersea environment and normal, the normal UV environment. It's quite different.
Yes, it's quite different. I think there is conductivity in seawater. I mean, we're generating relatively large eddy currents. This has been shown because there's other transport systems which suffered severely from this seawater conductivity. But basically, I would not, this is totally autonomous structure, subsea 4,000 to 6,000 meters. So there's it's totally different, for example, and I think this is what we might refer to wireless charging on EV, where you certain distances due to ICNIR standards, you would have certain field levels, like microtesla levels, which are specified and which you need to comply with. But for such, I think the standards are totally missing there, and it would not be that humans would be in danger there, but the standards are for the moment more targeting really interoperability of different type of vehicles rather than some safety.
Thank you.
Thank you.
Let's thank Professor for appreciation, the organizing committee has given you a bottle of wine from the University of Bordeaux.
Thank you very much. Thank you. So we are now going to let's introduce Sanjay Gupta from Airfield Alliance, and I'm going to share the panel.
Well, welcome to Unwired Day. We're going to take just a moment and set up for our open panel, which is going to be on startups and emerging technologies. So give us about 2 minutes and we'll get the panel going.
C'est bon, donc là en fait on laisse le stream allumé, ça va continuer, par contre on n'a rien à projeter pour la table, pour le panel. Si on n'a rien à projeter, je peux... Si on n'a rien à projeter...
Some microphones for
Yes, we have 2 microphones plus a little...
Oh, perfect, awesome. They're in order.
On va essayer, alors attends, dans les câbles, par contre, on va faire débrancher dans l'ordre.
I like it.
Oui, parce qu'elle projette aussi. D'accord. Alors on pourra voir si elle projette.
Let's see. And these are Asian links. Have a seat. Sit right here. And let's see, where is Igor? Can Igor make it yet here?
Est-ce que tu penses que t'es assez long?
just to see where it goes.
Igor's color. Yeah, exactly.
Yeah, they have two mics. Oh, perfect. Oh, okay. There'll be one for almost everyone.
Thank you.
Você o filme quê?
Well, I guess I'm. Hi, everyone. Take a seat. We'll get started. All right, for those of you who haven't been studying the program agenda in detail, this is what we're going to cover today in our Wired session here in the main amphitheater. We're starting with an open panel discussion, then we're going to have some presentations and demonstrations from some industry players that actually have applications and products in the market. We're going to do another set of presentations and demos in the afternoon, and then we're going to have a closing panel discussion at the end of the day on the future of wireless health. So, hope most of you will be able to join us. So let me introduce our first panel and our moderator. We're going to be discussing startups and emerging technologies in the wireless tower industry. As all of you know, there's incredible momentum in the space right now. Improvements to some of the first generation technologies are generating innovative applications, new components, new products coming to market, and it's really changing the game for everyone. So today, our panelists are going to explore what's new in wireless charging. We'll be hearing from them about what's driving change, how they're developing forward-thinking solutions, and we'll consider the impact of some of these new technologies, components, and products on the industry, and how wireless charging is evolving to meet the needs of diverse markets, consumers, and industrial applications. So I'd like to welcome Dr. Sanjay Gupta. He's President and Chairman of Airfuel Alliance, and he's going to be moderating our panel today. So welcome, Sanjay.
Thank you, Trish, and welcome to everyone. And what a wonderful conference, by the way, right? This has been such an amazing week. Great to meet everybody. And it's my great pleasure to actually introduce the panelists today. The first panelist we have is Juan Ortega from Bumblebee. He is at Imperial College and a co-founder of Bumblebee. He recently finished his PhD, and his doctoral research was on integration of high-frequency inductive power transfer systems. Juan, you want to introduce, add a few more words, talk a little bit about Bumblebee?
Yeah, sure. This way. So, in 2015, I applied for a PhD at Imperial, and I remember that I was asked to submit a presentation, you know, for the interview and everything. And I just thought to myself that I was just gonna make a video instead of a presentation. And I was not following the rules, you know, like strictly speaking, but I thought it was a good opportunity to see, you know, if the people that are gonna be hiring me or not are not gonna play by, you know, by that initiative, then maybe it's not the best fit for me. And I think it was great. While I was doing the PhD, we started getting really excited about the technology, and we saw the, you know, we considered that the level of maturity was getting there to finally start thinking of spinning out a company. And then we did. Of course, it's been very hard with COVID and everything. I actually finished my PhD in December 2019, but you know that was my main focus. And then, of course, the pandemic. So we've been dealing with that, and since then, you know, we've been running for like 6 months. We secured a seed fund of 750K GBP, and now we're about to build a
Awesome. Congratulations on the wonderful accomplishments. That's amazing. So next we have Dr. Stephen Elwood. He is the VP of Engineering at Medtronics. And he's a veteran of the NFC industry. He's a technical missionary. He spent 25 years in semiconductor engineering, and now he's leading the mission to use NFC for wireless power. So welcome, Dr. Elwood, and you want to talk a little bit about yourself and Medtronics.
Yes, I joined Medtronics in about 2015. We were bringing a new generation of NFC reader, reading through displays, which is what everybody expects to do now. You put your credit card on top of the display, and the NFC reader sits underneath. That's actually quite a challenging environment. And we generated a new kind of chip that was better suited for those high interference environments. And actually, we've got a lot of traction already in that system. In order to do that, we had to actually transmit about 2.5 watts of NFC, which is the highest in the industry so far. And then we saw that people wanted to charge wirelessly also. So we rapidly designed a chip that will actually receive power as well. So we now have a transmitter and a receiver of power in our system, and we're deploying that to customers right now.
Thank you. Next, I would like to welcome Dr. Eugene Nave. He is the CTO, and the co-founder of AtoLink. His research interests include design and development of wireless power systems for Internet of Everything, factory automation, medical applications. He founded AtoLink in
2020, and they are developing long-range wireless power solutions to realize the vision of a wire-free world. Welcome, Dr. Tanabe. You want to give an introduction about yourself and Italy?
Thank you, Sanjay. I'm Yuji Tanabe. I finished my PhD in 2011 in Japan, and after that, flew to the United States, worked as a research scientist at Stanford University for biomedical implantable device research. And then from that research, we found out that there's the good use of the energy harvesting for the circuit and some technologies, and we tried to spin off from Stanford and working at this data. Here today we have why I have CEO and the CEO is because we have two co-CEO and Joe, another co-founder of Data is the other CEO, and he's basically focusing on the business side and more focusing on the technology side. And we developed the application for more than 3 years, and then finally we could found this company in 2020. And since then, we have raised Series A funding last year, $2 billion, and also we raised about $3 billion government funding, and but we're planning Series B by end of this year or early next year.
Oh, awesome, amazing accomplishment. And by the way, just in case you're wondering, there is an empty chair. Paul Igor, the CEO of Electronic, is stuck in Uber someplace, so he should be here at any moment. I appreciate everybody's patience. But I think it is time for us to get started. And you know what I wanted to do, we've been talking wireless power, the technologies and science and physics all week. I see a lot of great power here. Every student, dreams of starting, having their own startup, being an executive at a startup. Maybe we start with why did you decide to go into the startup and create your own company when you probably could have had any job in the wireless power industry that you wanted? So maybe we start with you, one. You're probably one of the recent ones.
Yeah, I think I had a bit of working experience before I started my PhD. And, with engineering background, you're always looking to find solutions to real problems and actually making a contribution. And actually, the title of my thesis was Integration of High-Frequency IPP Systems, Integration of Applications. So it was always like making the thing practical, making it useful, finding something that would truly benefit from the technology. So it was just a natural thing for me to be part of this startup that we were trying to do. It was just very, very natural.
Awesome. I'd like to hear from Dr. Tanabe as well.
Yeah, sure. I think at Stanford, people, especially the engineering people, they always think of the startup. So it's more natural to go to startup instead of going to big company or doing your own or maybe professional like Joe and yes. So it's quite a natural process, and they have very strong thinking way that the engineer has to transfer the technology to the society to contribute. That's the most important thing and change the world. That thing we learned from the school, and so that's the base why we did this startup.
No, amazing. And by the way, so Igor has finally made it. And it's, I should introduce him. So he's the founder and CEO of Electronic. Electronic started about 10 years ago in his garage. But it has grown substantially. Now it's one of the leaders in the wireless power and the wireless semiconductor markets. Electronic, I'm like shocked. Electronics has over 300 patents now. I'm not going to try and figure out how many patents per year per person. Pretty aggressive numbers. So welcome, Igor. You want to talk a little bit about yourself and electronics before we.
Yeah, I start from the end. How was possible 300 patents? Well, I put in a graph, in a chart, because I'm still an engineer, even if everybody's trying to let me forget my engineering background. And I was looking at the graph. At the beginning, it was just a single patent, which was about the capacity wireless power. And then another patent after years, and then two, and so on. Then if you monitor what we did, hiring more engineers and so on, you see that nice shape, which is the exponential one. And you say, okay, so I'm building something that is not related to me, because it's impossible for a single person, but it's an innovative ecosystem able to generate innovation, even if the founder is doing almost a totally different job today. So this is what I really like about the company. And so now we are 70 people, we are hiring, I repeat several times because this is important and finding talent is important. And usually stuff like this, I say, okay, this is the next department and the next project that I would like to launch. I decide who is the team leader of that department, we agree what we want to do, and then I tell him or her, hire whoever you want. Okay, this is your team, your choices, and of course I support you in everything, and then in a year we are able to have significant results. And this was since the very beginning, from 1 person to 70. Now the next goal is to keep more than 100 employees.
Awesome, awesome. Thank you for that. The next question I have, and this is something that I have struggled with myself, is doing a PhD and completing it is very different than starting your company and being successful. Do you want to talk a little about some of the challenges you faced and what skill sets were needed above and beyond what you already had proven that you did to succeed in this new world? I don't know, you can start anywhere.
Well, maybe I can speak about my experience. I mean, I've been involved in startups since, well, actually 40 years this year since I graduated. All my life. The thing that the education gives you is curiosity, and that's absolutely vital to anything that you do in this kind of space. You have to invent new things, and I'm crazy about inventing new things. That's why I'm always in startups. That's the essence of what you learn, to learn how to learn. And that's the most important thing. And then when you come up against problems, and there are always problems, always problems, you can do it, a test in the lab, and it looks great, and then you can put it in a watch, and it doesn't work anymore. So you have to have that curiosity also helps you with that. And then, you really have to push and solve problems. There are occasions because you solve the problems, etc. So that's really what carries you through. But then it's all, in my experience, it's all about experience. Because I'm still applying things I learned 30 years ago to today. So we had a problem a few weeks ago, and I said, 30 years ago, I did this. Does this apply? And they go, oh yes, okay. And you patent 30 years after my own patent.
Thank you.
I think it's very difficult to address the fact that we're focusing on hardware, and I find that getting investment and things like this, it's quite difficult if you have that hardware element, that it's not just a company that is doing software by subscription or something like that, which is much more easy to make a case business-wise. I guess it's less risky. So let's think about that from your experience.
What I was going to ask is, did you have like support? Where did you get the support to understand even like how do you go about raising money, for example, as a startup out of a university? Or what did you do?
So in our case, so sometimes you have to let the baby go and you know that your expertise has a range. You're not an expert in everything, and you need to find allies that will understand, a better business case, and they know their way around how to raise money. So it's building up a team in my opinion.
I'm curious to hear what you had to do.
So yeah, we also have a similar problem with the funding to kick started. So we just use our own small amount of savings to research for maybe cut 1 to 2 years to get the first funding. So we're almost gonna give up, but luckily we had the chance to show in the TV news when we could reach a very long distance and while starting more than 20 meters, and everyone was so surprised. And we, after next day, we got more than 500 company contact us, and our server was down, so we couldn't respond to them. But anyway, I think that was the breakthrough. We try not to give up and until the goal. And I think it's almost similar process as the PhD, because you have so many data, you cannot pass the papers. It's same as you cannot fundraising from VC because VC doesn't understand our business. At the end, they figure out that it could be really useful for society, and we have lots of VC tracking this task.
Amazing. So, Igor, how did you move out of some garage?
Well, of course, fundraising is one of the most complicated parts, much more than the technological part, honestly. So, with endless funding, today we were much bigger, and we were able to fail more times to select the best technologies faster, and so on. So, for sure, what I suggest to whoever wants to start a new business is to be very resilient and ready to everything. Yes, to put our own money, of course, which is good, not because of the amount, but it's good because the investors can see that you strongly believe in what you're doing. And then I don't fully agree on the fact that there was a moment in which digital was everything, and now in artificial intelligence, which is statistical analysis of data, and so it is. But now it's our moment, honestly. So now power is a super trend, it's the new sexy thing to invest in. And so we are here, we can get more or less whatever we want. And I saw this personally, because at the beginning, the first deal was terrible to me, and to my cap table. And now the last one has a very nice valuation, and we raised more than $30 million. So I see that it's important also to set the expectations with the investors and to say no to most of them, because otherwise you just give up too early and you just get not enough capital and lose too much stock, which is not for you founders, it's for the next round. So having a nice cap table is a nice, important thing that I learned learning a lot on my sleep.
No, thank you. But I think these are all the skills, right? Raising money. You don't necessarily learn when you're doing your PhD. Dr. Tsunami, you brought up something that I think is also very important, which is the market, right? Getting on the TV, everybody understands what happens after you are on TV. But talk a little bit about how you got on the TV so that our audience understands the hard work it takes to make that happen.
Right. I think it's all about the connections, how many friends you have, and one of the co-founder, Joe, has his senior friends asking him whether you want to be in a TV show or news, and yeah, of course, we do that. And that's just a very simple thing that connection helps a lot. So, or somebody to support us, that's very important.
Have you been doing marketing yet?
No, not yet. This is being filmed.
Yeah. Yes, he is doing marketing
there, right? So by the way, this is all about you, so get your questions ready, and you'll get an opportunity to ask our panelists all the questions on their mind. Technical questions are fair game, but I think we talk technology all week, so I would much rather talk a little bit about things that we haven't talked about as much. Another important aspect that I don't believe, at least I learned in school, was how to make your first sale. Right? You're getting people to take their wallet out and get their credit card or some dollars or euros or whatever is way more difficult than I ever thought it was going to be. Talk to me about your first experience of the first sale and what it took to do that.
Well, I can tell there are two ways to make sales. One is to say yes, which was how I started. Okay. And this is good because you survive at the beginning, but you focus the company a lot. And so this was the main problem. You learn a lot because you learn how to make real products, which is something super important. But you really cannot follow your path and roadmap. Then there is another way when you are decently funded, which is to say no to almost everybody and just select a few significant customers. And in that moment, the main problem is that they are giants and they have everything to lose switching from their current reliable supplier to an unknown company made of tens of people. And so in that moment, you really need to show that you are able to execute very well. And that, what I did was to say, prove us. It's literally for free, the first. And do you want prototypes ready for mass production? Do you want to see our supply chain is certified? But everything is on our shoulders, not on the shoulders of the customer. Because a giant customer just have everything to lose selecting us.
Dr. Owen, I'm curious to hear about your experiences with the first sale in all of your startups.
Well, that was sweet because we're in exactly the same position. We have chosen 6 sample customers for our research. Well, one of them is a smart device, essentially a watch, but we're working with them and we're working with them day by day, and we're going to see them, we're proving out, and they come up with some new mechanical designs, and we're at a very good efficiency, and the new mechanical designs have killed it, so now we have to go back and find out why that happened, and so on. But these are a lead customer, they're what we call a learning customer, because when you put a new technology to market, you know the theory, but the practice is very different. So you really have to select, as you say, a few. You could go to everybody and say, yeah, I have this great product, and then you'll die because they're just swamped with support. You have to select a few, you have to learn with them and say, and tell them, be upfront. We're learning with you, you'll get the best deal. And if they need you, they will come. If they don't, okay. But we have 6 customers that we're working with. Smart ring customers, I'll show them later. Smart glasses, smart watches, wearables. And the problem with wearables is they're all different shapes and sizes, and they all come with different challenges. And we've chosen one from each because of that. So we can learn, and then once we've honed our skills, then we can go to the mass market. So we have this. And by the way, if you buy one of these, you'll be able to.
Awesome, awesome. You know, one thing that I think both of you said, which I so agree with, is as growing up in our careers, right, we all like to be pleasers and say yes. But learning to say no is a very important skill. I think in running any business, I was taught you have to learn to say no to 80% of the requests, whether it's an engineering feature, whether it's a potential customer. And that's not easy for most people because we want to please, we want to make people happy. We don't like to tell them, no, I'm not interested in you. So that's a very important point, and I think we all need to get a little comfortable doing that. Anyways, you know what? It's time to open the floor for questions from the audience. So if you have a question, just raise your hand. We'll get you a microphone. Yeah, so ask questions. Otherwise, we will keep going here. So maybe a little bit of a technical question, right? So both Pantronics and DataLink are kind of serving the low power market. I think if our audience here would love to understand how the two technologies are different and why the two technologies need to coexist together. I don't know, Abdul, you want to take it first?
The two technologies, near field and far field.
Right, but they're serving similar kind of power needs.
So first of all, wireless power is just a tool. It's not the goal to do the wireless power long range or whatever. Again, the customer, what they want, that's the most important. What kind of solution we can provide. For example, we have the, for example, factory automation problem is there. The robotic hand, there's a combo sensor, more than 100 sensors of one robot. There's those sensors are connected through wire, and since this robot hands keep moving very, very quickly, and those wire breaks and the factory line stops, then that brings a huge opportunity cost. For example, large Toyota Motor Company losing more than a few $10 million at just only one factory. So that's why they are so eager to get rid of those wires. And so since then, you can apply the battery to those sensors because you need to change every 3 months. You need to have a maintenance guide and then take more cost as well. And the second, they cannot ship out those sensors to overseas since if there's battery included. Those kind of things are also not good for the environment. That's why they want to have a completely wireless-free systems to operate those factory lines. That's one of the reasons. So we just find those pain points application, for example, and then broadcasting long range, not necessarily long range, but creating the equalize the wireless power in the space is most important for us because it can cover all sensors. You don't need to worry about the location or distance. And at the end, sensor operates and picking up the data from the sensing and then send it back to the operation machine to move the robot hands. That's the solution that we're looking for. That's why we try to solve this problem, not including MyStar, but also data communication and sensing.
Thank you. Marta, would you want to talk about?
Well, NFC serves a slightly different niche. We do near-field communication and near-field charging, so you can charge things up to 10 millimeters between two coils, depending on the environment. And we have to tune for that so that your resonance happens at that particular distance. But the beauty of NFC is it's now everywhere. I use it 3 times a day on the tram, paying my bill. But also, NFC is an established technology in that we can communicate with NFC also. So one of the most important things that our customers tell us is they want to be able to open a transparent channel on the NFC, superimpose over the charging itself. So as you're charging, you're also communicating. You can update your watch using NFC. So if you have a firmware update, you just put it on the charge and you say, give me a firmware update. You don't need a separate Bluetooth for that. So that's where NFC comes in. We're not talking about large powers, to say up to 1 watt is where we see the sweet spot. Smart rings and things, yeah, you can't put 1 watt into a smart ring or burn your finger. But you know, it's low power, but the communications part of it in the same chipset for free is the key.
Awesome.
I have a question over here.
Yeah, go ahead.
I wonder if you can talk about the business model for your products. Because it seems to me that it looks like a price competition. That you have putting a lot of effort, work into developing this really good and better technology, but you have to offer it to a lower price to be able to enter into the market. So maybe you can talk about that, how the business model works.
In our case, we're a semiconductor company. We sell chipsets. We sell a read chip, which is also the charger chip. We sell a tag chip, which is also the listener, what we call the listener, receives the power. And yes, they sell at very low cost. We have to make tens and hundreds of millions of them to make money. That's clear. But as I say, the beauty of NFC is it's everywhere. So that market is there. We can sell tens and hundreds of millions of them. We have to compete with competitors in the space. We're not the only people in the NFC charging space. There are two much larger companies than us actually to do that. So we have to do it through innovation. So we have to mop up as much functionality as possible into our chip. So for instance, our receiver chip also has a charger, a lithium-ion battery charger in it. So we actually replace two chips with one chip. So you get the charger for free. Yeah? Whereas that's also a $1 value separately, and actually a bigger chip than ours. So if you stick around later, I'll show you how big it is. That's what you have to do. You have to create a value proposition that then is competitive with wired, because that's always a competition, and with our own competitors.
I totally agree with this approach. We do the same. So semiconductor company, so the typical gross margin of semiconductors, and in order not to see the chip cannibalized too quickly by Far East competitors, the only way is to have a unique selling proposition, which means that usually we tell them, look, with our chip you substitute 4 chips on the typical PCB, and you have this extra feature which is only with us, and this is the reason why we say the global cost of the solution is maybe lower. The chip is not the cheapest in the market, but you can get your price, and at the same time we can get payment for the hard work that we did.
You know, I think there's a follow-up question that's maybe an interesting one for our audience, which is, you started with wireless power and suddenly you're making chips, right? How did that happen? And what was the rationale behind it?
You try to use external microcontrollers and a lot of digital and analog peripherals outside of the chip, which is where probably most of us started. Then you are not able to show to the customer something that makes sense for them, because it will be too expensive, the board will be too big, and there's no way to sell it. So for a prototype, everything is okay. But if you want to be in mass production, millions of units, tens of millions of units, which is more or less where we are today, then you really need your own chip and your semiconductors.
Very good. Okay, let's see what other questions we have. Everybody needs a little coffee here today. Yes.
I have some. Maybe I have one.
Sure.
I could try to speak up.
I'll repeat it.
Okay, thank you. I would be interested if you also maybe took a look at the interoperability of wireless power transfer systems, for example, following the key standard at 100 kilohertz and interoperating with near-field communication at 13.56 megahertz. Because NXP, for example, is also just suggesting that you use then NFC as a means to communicate, communication link between the receiver and the transmitter of the wireless power transfer system in key. Have you taken a look at this already, or are you exclusively focusing on NFC charging and communication?
Thank you for the excellent question.
That's a very good question, and the answer is yes, of course. We have a partnership with Renesas. Renesas is number one in China, at least that's what they tell me anyway. I can't speak for them. And we've been working with them for over 2 years. And they want to use a combined Qi and NFC charging system for exactly that reason. But they want also in automotive is becoming very interesting because they want to use NFC for foreign object detection before they start charging with Qi. Because one of the things is if you want a 60-watt Qi charger, for instance, and you put your credit card on there, you'll just fry your credit card. So, I think
if you are lucky by it, there's no fire coming out there. That's a good thing.
So, I think Volvo wouldn't be very upset if their customers' wallets started going in. So yes, it's a very interesting add-on to the technology, and that's why Renesas came to us today.
Thank you.
And by the way, that has happened. I have put NFC cards on fire by mistake. Okay.
Not an electronic charger.
No, it was not an electronic charger. Any additional questions? Otherwise, I have one question. And this is something. When you're commercializing new technology, which at the end I think everybody here is emotionally wired to do, and always find there are what I would say unintended consequences of the technology that were not anticipated prior, that are like little surprises down the road. I would love to hear what surprises you faced and things that you had not anticipated when you were starting the project and trying to commercialize it. Maybe we start with you. What have you faced till now?
Well, what can I say? It's a little bit like research. Sometimes you start doing an experiment, and then you realize that that experiment gave you insight for something that you didn't foresee in the first place. It's like you start doing a wireless charger with a lot of microcontrollers and other boards, and then you realize that the actual value that you're bringing is manufacturing a chip that contains all of your IP. So it's a little bit too early for us to be thinking of something like that in terms of the business. But we have been approached by many people looking to integrate our technology in different applications, and as you guys were saying, you cannot just say yes to everything, and at some point you need to focus on something. So I think one of the biggest attractions from our technology was integrating IDP systems in drones. That was going to be the first idea of the company. We were going to focus on that, but actually, business-wise, it looks like it doesn't make sense just yet, at least with our technology. So we shifted it to something that is mobility, which makes a lot of sense because as one was asking before, you need the added value of the wireless charging to make sense financially. So you're bringing an add-on to a product that exists, and that add-on needs to be worth, what it more than what it costs. So that's like our.
So you were saying you had to do an MBA on the fly.
yeah, that sounds like a brilliant idea.
Very good.
I have two examples of this kind of unexpected results. One was one of the wireless technologies that later I will show you. And it is wireless. Wireless is my first love and passion. and then you have to survive. And one customer told me, but you make also adapters. No, I don't make adapters, honestly. You can purchase any kind of adapters everywhere. And then I said, look, this wireless technology, if I substitute a single component, it's probably the best adapter in the world. And so we filed another patent, and now it's what we are selling, our best seller. So, and this was coming from a single customer suggesting the idea that something that was wireless was recyclable in a totally different field. And this was one field. Now, with our first ASIC, which is in the market, we have made that ASIC for us and to sell with a firmware made by us, programmed to deliver the functionalities that are our own architectures and stuff. But the German customer told us, yes, but Fiat is not delivering any microcontroller to the market, and yours is better. So can we purchase as a general purpose microcontroller? And we are not ready for this because the level of assistance and what you need to let other developers develop on your chip is totally different than teaching 10 engineers how to use your own chip. But this is another unexpected result of what we did.
Dr. Now you want to talk about
yes, I have one example. When we went into the wireless charging market, NFC is not really designed, or wasn't really designed for efficiency. You have to get a certain distance, you have to be a car at a certain distance or whatever. And when we went into it, we thought 50% efficiency should be enough. Because we're only talking about 1 watt. If you use half a watt, it's not going to cost you money. Actually, it's very important because when you're charging very small devices, if you're charging at 1 watt, there's half a watt of power being lost if you're 50% efficient. And if you put half a watt into something of the size of a ring, you'll never be able to wear it again. It's too hot. So it turns it on its head for us. It's not about efficiency, it's about heat. And it's a very important, they are two facets of the same thing, but you have to think of it in a different way.
That is so true. Generating heat is the easiest thing to do. Even wireless. Awesome. Any additional questions from the audience? Okay, I'm being told we're running out of time as well here. Maybe before we end, I think I would love to hear what advice you would have for the students here and researchers here looking to start their own companies. Right? To me, there is no greater joy to see a lot of the hard work you've done, not just in paper, but actually being realized. Right? Like you were talking about. What advice would you all have? And what can you do? What lessons, what knowledge can you share in your wisdom?
When you say go for it, simple as that.
Awesome, be brave.
I think I talked about curiosity, be curious, and follow your curiosity because it will lead you in new directions. And sometimes you come against a brick wall or a seeming brick wall. For instance, I was part of a company called the Active Book Company in 1989, and we made a handheld computer that you wrote on with a pen. And I did a little thing saying, you want this to be multimedia, you want it to have sound and graphics and all this sort of stuff. And I said, 17 years later, Apple came up with the iPhone. I said, that's what I invented.
So yeah, starting your company, I think most important thing is, especially for the scientists, they love their own technology. So since then, so they more focus on the technology, not the business. But first, you need to find your customer. Otherwise, it's not going to be like that. So finding customer, finding application is the most important thing. And after that, you fit your technology to that business. That kind of process, like instead of product but marketing is most important thing. I would say.
No, thank you. And if I can just summarize what you said, I think this is what you were saying too, right? Start from a place where a product needs your solution rather than I have a solution, let me go find some place to stick it.
It's application pull instead of technology push.
Very good. I think if those are 4 words to remember. Awesome, Igor.
Yeah, I'm without perfect. Everything is correct. Fundraising, and fundraising is related with, which for scientists is complicated, to being able to explain to non-technical audience what the hell we are doing, which is not easy usually because they don't understand, they don't like it. And so it's very important to communicate in a very simple way how they can make money with your ideas. So this is one other important thing. And hard work. When I see so many young students and engineers coming to my company, already talking at 25 years old about life balance, life-work balance. So I think you are young, you must be in the panic zone as much time as possible. And that is the learning zone. If you're not there, you really don't know what your limit is. And after a while, you are always better and better, but you must feel the pain. And this is something that I suggest to young students.
No, absolutely, and I have a famous basketball coach who coached me not for basketball. He shared with me something very similar, Igor, that you said, which is if you want to grow, then prepare to be uncomfortable. Right? Prepare to sweat. There's no easy way to do the learning. There's only hard ways to learn. Right? And we all celebrate entrepreneurs when we have success stories, we glorify them, but nobody understands the blood, sweat, and tears that went into it, and we don't share a lot of that. So thank you for bringing that up and telling people work hard. There is no other easy way. With that, thank you. Thank you for attending. And by the way, our panelists are available. Ask them more questions. I'm sure you have. Thank you, and we'll see you around.
Thanks, everyone. We're just running a few minutes behind, so let's try to reconvene, say, 10 after. So take a break, and I have a little treat for all of our panelists. We'll see you in 15 minutes.
These are numbered 1 through 4, and they're the wines we had last night. So if you had a favorite, you can fight with each other over your favorite.
I won't fight.
Yeah, so you'll see there's a number on there.
Can we take a picture with you?
Oh, absolutely.
Of course.
Absolutely.
We don't want the 3, right?
Igor wanted it.
I want the 4.
You want one?
The
Hopefully you all want a different one.
the one. I like the one.
You want one?
Okay. That year with a lot of rain. That is
Thank you very much. Okay. 1, 2, 3. 1, 2, 3. Just
Awesome. All right, so who, you wanted 3, Igor?
No, one.
Oh, you wanted
one was the worst one. It's okay.
Come on, take the best one.
No, I don't want the best one. I don't understand.
No, we
There's 3.
transport heavy stuff, so we are used to use a lot of from where? Norway.
I like the one which was the ring here.
They're really very cool.
Which one do you want, Stephen? 4? Okay.
Many users.
They're all different border ones. Is that good for you? Okay. Juan, you're number 2.
Thank you.
Thanks so much, guys. That was great.
Thank you.
Yeah. No, thank you. Thanks for sharing. It's amazing wisdom. No, thank you. Thank you.
So what's the schedule for the presentations?
The email that you sent at midnight 33.
That's about when I got into my hotel.
Rhea's first. Yes, you're this afternoon.
Okay.
Yeah.
I have some videos.
About 2 o'clock. Does that
So,
work?
yeah, I'll have to rush to the airport afterwards. But yes.
I can switch. When are you leaving, Igor?
We were thinking after our panel, so
I would prefer to be slightly earlier.
Let me ask Thomas. Can you go early? Can you go later? How do you leave?
We don't leave, but people, just for people that had some people were interested to see when we were around.
so I have the same problem. So when do we finish? Because if it's not too late, I can switch and I can support you.
With you, Steve, so you can go earlier. Remind me though, you have some heavy videos in your presentation, right? There's a couple of videos, so I just want to make sure I have the right video.
I tend to.
And you have a video too. Okay, that's what I was thinking.
But it was like on freeway.
Yeah.
Videos after videos.
Well, let's do that then. I'll move you and I'll put Gordon in the afternoon.
Yeah, it's just my flight's 4:30, so it's, I've got to get to the airport.
Oh, yeah, I should be late. And then you guys can keep your times.
So the questions are not the ones that I received, but we can present a presentation.
Oh yeah, I've got the presentation.
I was thinking about modifying it if I present that.
You can. If you just like either send it to me or like bring your own computer and we can just switch out real quick.
I can work on it right now. Okay.
Okay.
Do you mind if I start using the board to present it?
Yeah, go for it. I do want to test it. That's why I want to test the videos.
That's what I want.
So this is in my PowerPoint right now, which may or may not. Like everybody's lined up together. Oh, yeah, no, you can take it off for now and I'll put it back up later.
Yeah, but for the next presentation, are you using your computer?
I was planning to, unless we have to switch. So that's what we're testing right now. Maybe it might be better to pull it more up.
Gordon, do you have the presentations? Yes.
Yeah, let's actually test it and make sure.
I didn't see you since 2 days ago. You left, you gone.
No, I left a little bit yesterday.
Oh, perfect. I was worried. I said, no, you not visited Bordeaux.
I'm just talking to
Don't.
someone.
Hoping we would.
You don't have a
Hey, Gordon. Do you mind switching with Elwood to do the afternoon instead of the morning?
It's huge time.
This was the middle presentation in the afternoon, like 1:55. Okay, cool. I told him he would care. He's got like a 4:30 flight.
See the factory, right? What are you doing in the factory day?
Oh, can I use my laptop PC?
Yeah.
Okay, thank you.
Absolutely. You're Rio?
Rio, yeah.
Oh, nice. I'm Trish. I hadn't like met you in person.
Yes. Thank you very much.
You were taking great pictures. I'd love to get a
Yeah.
What a weird thing.
Do you want to use a pointer?
Do you have one with
Yeah,
you?
yes.
Oh, that'd be awesome.
So during
Sanjay was going to bring one and he forgot it.
I like that to make an announcement at my normal time.
Robot is dead.
What is that?
Like storm out. Okay.
I'll be here.
Okay.
Don't worry. One video is not playing at all.
One video is not?
It's dead.
Because this is the deck you just sent to me.
Yeah, no.
Yeah.
It's very interesting. So I might have to use my computer after all.
Yeah, that's okay. I mean, it doesn't hurt to take 30 seconds to just switch it out. People can relax.
Okay.
Yeah, and you're going first.
Yeah.
You're going first. So what I'll do is just close now and then plug you in. Does that work? Yeah. Oh, that's great. You'll be good. I'll do just a little introduction. Okay, fine. Yeah, as soon as everybody comes back in. Okay. And then we'll be good to go. Yeah, we'll probably be a little late. Okay. You know, bad on that one. Battery dead, maybe?
Yeah, I think so.
What?
Because it's vibration.
Yeah.
Oh my God.
The connection.
Excuse me?
Do you know why it's not connecting?
I don't know.
That's weird.
We can check if you want.
Yeah.
Can I use this one? And try
Yeah.
It's yours.
Yeah. Yeah.
Okay.
Would you prefer this night or
This one.
So what time do you start?
In, let's see, about 9 minutes.
Okay.
You have time. We'll take an extra 5. It don't take that long for everybody to come back. We have a bunch up there, don't we?
I changed the batteries.
Oh, nice.
Me too.
Your last name's Asala?
Iwasa?
Iwasa?
Yeah. Yeah.
Can you go to the
Maybe. Yeah, I think in 8 minutes.
8 minutes?
We'll start. Yeah, take your time.
what's the strategy to round up everybody? And what time do we start here?
We have, we're supposed to start in like 3 minutes,
Okay.
but we were, running a
Yeah,
little
we're
behind.
probably
at the
running a little
beginning,
behind,
so
okay.
it's okay.
Because we will need
People
some
start
way to
funneling
get
back in.
everybody back somehow, I don't know how.
It may be just going out there and saying
That's
we're
what
going
I'm
to
thinking,
resume.
we may need to do that. Yeah, very appreciable.
Are you juiced up, Thomas?
Yeah.
Did you find your plug?
Yeah.
We are in the middle of it. Okay.
Just correct it. So
What's going on is
I have some practice in that. If I know you chasing
yes, that's like this. So that's your default. I think that's what this I can do.
だって多分その検査をした時にもらってきたので、こちらのことがスペシャルにあるので、ちょっと僕の方ではない。そうですね、そういうことです。
We'll get started in like 2 minutes, okay?
This watch as well as charged. I know. Yeah, I speak to them every 2 weeks. I was supposed to speak to them yesterday.
Should we wait another few minutes, Andre, or go ahead and get started?
I think we should get started, I think otherwise we'll keep falling behind.
Yeah, agreed. All right, well, welcome everyone. Our first presenter today is going to be Rio Iwasa. He's a PhD and co-founder of Aderlink. While at Okaya and Company, Rio served as a project manager for automatic driving, electric, and flying car projects for the Toyota Group, and engaged in projects to develop new technology for mass production. He co-founded Aderlink with Dr. Yuji Tanabe in 2020 with the goal of realizing a wire-free digital world through their long-range wireless power technology, AirPlug. Today, he's going to introduce AirPlug to you, and also share about building Aderlink's business and their penetration and creation of new markets. He'll also highlight some use cases and discuss the direction of the business is going to go in the next 5 years. So welcome, Ria.
Thank you.
So hello everyone, my name is Rio Iwasa from Aderlink, and thank you for inviting me to this special presentation chance. So, So let me introduce myself. My name is Rio Iwasa from Aderlink, and I work at a trading and investment company in Japan. And there, I was in charge of the project business development. And for example, I developed a new technology to the mass production technology. And customer was, for example, the Toyota Motor Corporation or PSA or Metro or something like. And actually I'm not technical engineer, I am the business development. So please ask me the question of the business development, how to do business development. And so as you know, the wireless farming is booming now. We already changed the regulation and created new rules in Japan. However, we have a lot of problems in the world. So the biggest problem is we don't have common rules all over the world. So for example, when you launch a new product to the market, you have to, for example, submit complex documents, or you have to be followed to each country's the rules of regulation. So I think this is a bad situation because some of us can use wireless technology, but most of us, we can't use wireless powering technology. So we need common rules all over the world. We need to create a new regulation all over the world. So today, in order to create a new rules, I will introduce how we make a use case and how to develop the new technology to the markets. So have you ever imagined the place where you can get energy anywhere in the space? So you can get energy in the space anywhere. So this is, I think, maybe amazing. We will try to achieve this vision. So first of all, let me introduce the TV show, which is broadcasted in 2 weeks ago. And this video is focused on our company and our technology. Yes, and this TV show is one of the famous one in Japan. So you can see the AC controller, their place, and there are a lot of sensors which is sensing for example, the temperature, humidity, and also the CO2 levels. So when you try to, so it is very difficult to connect the table to each tables. Because when you change the assignment of the table, it is trouble sometimes. So there are requirements from the development company, who is Takanika Corporation, who want to make each fully wireless. So you can see our receiver side, which is composed with multiple antenna and multiple sensors. And also you can see our transmitter, which is sending the 1 watt power, and also which is passed through the regulation in Japan. So this is our wireless powering system, and sensing some data and send back to the AC controller. So right side is our power transmitter, and left side is our receiver, and sending 1 watts and carries a few milliwatts, and sending something later, and yeah. And so also he explains you can get power in the space anywhere. And also he says it's amazing. Okay, and next one is another application called the security system. The application is a door detecting sensor, which is sensing the door is open or closed and sending back to the data to the security system. And also, we are going to try to develop the new market is medical implant devices. So anyway, we already launched a new product to the market. I think this is the first mass production product all over the world. So go on the next slide. So as you know, the Yuji from CEO and CDO researched at the Stanford University, and target application was the pacemaker. So we try to transmit the power from outside the body to inside the body. So why now? This is, I think, the most important to develop the business. So first one is the regulation. So as you know, we already changed the regulation, the new rules in Japan. So we can use the wireless powering system in Japan already. And second step, 2024, we will make a new rules. We can transmit maybe 5 watts. And after that, I think we have to create common rules all over the world. And second one is move as law, as you know. So power consumption of BLE is keep reducing. And so that help our business more easier. Because it's very difficult to power up the transmitter side. And so there are 45 trillion sensors in 2040. So we don't have enough people to change batteries. So 3 key features. So first one is we can transmit the power more than 70 meters, which is amazing level, and I think which makes us a top runner of wireless powering technology. The second one is all-day communication. So for example, in the factory automation, the customer demands us real-time communication less than 500 microwatts. And we already achieved those ones. And third one is operation freedom, which is realized by our antenna design. So for technology, first one is a multiple antenna, and second one is impedance matching. So yeah, this one is maybe briefly. So use case. So I founded this company in 2020, and now we have 3 business domains. The first one is building management. As you know, I already introduced the video. We already launched the product, mass production, 2021 November. And this year, our revenue from the building management might be $5 million. And the second one is the factory automation for the robotic sensors. So this is, we already have a big contract with a leading sensor company in Japan. And we are going to launch January 2023, and the business scale might be $60 million per year. I think this is amazing. And some of this biomedical, we are going to launch 2025. So let me introduce the factory automation business. I think this is a clear application of the wireless powering technology. So you can see the right side, the GIF pictures. So this is the manufacturing line. And so, there are a lot of sensors which is attached to the robotic hand. And robotic hand moving very quickly. And also, of course, the sensors is powered by the cable. So that means the cable breaks down very frequently. This is a big problem for the factory automation manufacturing. Because, for example, the Toyota Motor Corporation's productivity per 1 minute might be $30,000. So once the cable breaks down, the Toyota has to pay a lot of money to recover the manufacturing line. So we are going to solve these pain points for the manufacturing. So this is the real manufacturing lines. So generally there are more than 100 sensors. You can see the 2 poles, 1 meter. Between the poles, there are 100 sensors which is attached to the robotic hands. So go on the next slide, the building management system. So I already introduced what is the building management system business. So here we already launched to the mass production item, transmitter and receiver and total system. And this is the first example for the wireless powering system. And someone is biomedical implant devices. This is our origin application. We use our technology to the pacemaker or something like inside the brain, like this. And finally, this is a value chain OS, which we finally want to realize. So what is a value chain OS? So we are going to use our technology to the, for example, manufacturing lines, for example, the logistics, for example, retail, for example, biomedical or the building management system. So that means we can get a lot of information from each domain. So that means we can use our big data to feedback. We can do the feedback. For example, the retail, we can realize the dynamic pricing. We can change the price dynamically because we can get biomedical data from each person. And of course, we can understand where is the people in the supermarket and who is watching the product. And so we can we can change the pricing tag data, of course, powered by the wireless powering. Okay, that's it. Thank you very much.
Do we have any questions for Ria? Go ahead.
Sir, I checked, but I have a question regarding the transmitter and the receive power for your application. You said the maximum is 70 meters. What about the power?
Okay, the power, we can get power on the receiver side, might be a few milliwatts. We can handle the LED lights.
So what about the
transmitter power?
Yes, the transmitter and the receive power.
Okay, we can transmit 1 watt and receive a few milliwatts.
So in the 17-meter distance?
Yes.
So you should, what about the size of your device? So should be good antenna and
the transmitter antenna maybe 8 dBi, right? Maybe. And receiver size is maybe the data size, maybe right this size. Yeah.
Okay. So is it, just is a fixed transmitter and receiver, right? It's not.
No. You can move the receiver. Yeah.
Okay. In the area of the 70 meter. So.
Yeah, exactly.
Okay. So it's for indoor, right? It is indoor. For what have you tried to do it for to see what's in the outdoor or I mean to go for longer range? Exactly. So what the kind of the milliwatt is that good enough for the supplying the
Yeah, yeah.
okay. Thanks.
Thank you very much.
One more question. Over there.
What frequency are you using, and is it beamforming?
Yes, we use 900 megahertz. And we actually don't use beamforming in the, for example, the use case for the function automation or the building management system.
So you said there's 100 sensors, and is it receiving it simultaneously, or is it done by time division multiplexing or something like that?
So actually, the receiver side can get your energy at the same time, more than 100 receiver side. And I think it's very difficult to send back the data. We can use 2.5 gigahertz. It's kind of the BLE, sending data sent back to the maybe the factory automation system. This is very difficult. So actually, in rare case, maybe we can transfer the power to might be 20 or 30 devices at the same time.
So you're communicating with a BLE with 100 sensors?
Yeah, actually, yes. Not yet. Just the power.
Time for one last question, if anyone has one. Yes, Sanjay?
You had talked about the regulations in Japan allowing you to set 5 watts in a few years, which is actually pretty good news. I'm actually curious to see if you have information on why the Japanese regulatory bodies reevaluated and increased, and do they have data that they would be willing to share with other countries so that we can have like universally the same?
Okay, I think so. If I understand your question, for example, so in Japan, regulation is very strict, but we have tried to change the regulation for more than 10 years, and I think we actually found a clear application for the wide current system. So maybe the government changed the regulation, I think.
I see.
Yeah.
Thank you for that. Yeah.
Thank you very much.
Thanks so much, Vega.
Just the last question. How big is the device?
Oh, sorry?
How big, I mean, the size of the device?
Devices? Okay, maybe we can show the demo. Kato-san. You can see the demo. Yeah. We have an exhibition booth. Yeah.
Because the one should get less than, I mean, the size should be big if you want to get the range of the milliwatt. In the 70 meter, if the gain of the receive power is around 5 dBr demand, so less than milliwatt. The antenna is the only. Please come to
It worked. All right, make sure that you go and check out AirLink's booth, then you can actually get a little bit more detail on the technology that Rio just presented. I want to reintroduce Dr. Stephen Elwood. You met him a little earlier on the panel, but he's here today to share a little bit more detail about what Plantronics is doing with NFC.
Okay. Let's test the demo.
Got a mic?
I just brought one little application with me. This is a wireless mouse which is also wirelessly charged. It was an interesting, we demoed it last week at a trade show, and the story goes that this guy turned up and he was looking at the mouse and he was saying, oh, this is good, this is good. And our sales guy said, hello, are you interested? He said, yes. And he said, what company do you come from? He said, Logitech. It says Logitech on the mouse. This was just a demo we put together. We removed the batteries and we put our wireless charging system in there. So he's very interested. That's good. Most of you will have in your pocket something to do with NFC, normally a credit card. NFC goes back a long way, starting with RFID, and the technology now is 13.56 megahertz, which is a subset of RFID, and it's standardized a long time ago and is used by credit card companies. We sell into that space. We do credit card readers, as I mentioned before, especially ones that sit in the display of handheld devices. We've got a big market. We've got two big customers who are doing handheld devices. And again, when I paid for my taxi last night, he pulled out a device actually that had the Plantronics chip in it, which was great, and I paid for the taxi. So it does work. It's good. NFC allows two-way communication. As I mentioned before, that's a very important part of what we are trying to achieve here. But because we can do 2.5 watts of transmit, we can actually do quite substantial power transfer, up to about 1 watt is what we're doing at the moment. And I'll show you how we do that. So we're not the only people doing this. The NFC Forum have standardized this as the wireless charging system, and we are one of a number of companies doing this. So they have a thing called a Polar, which has normally connected to power, but actually one of the companies we're talking to has a battery-powered Polar. So that's an interesting situation. And it's again the smart watch. They actually, rather than take the watch off, you put the charger onto the watch. So they never want you to take it off. You put the charger onto the watch, you charge it, and then you charge the charger separately. And then you have, so we're showing a ring here, but a listener, which has to be charged. Typically, these devices are wearables. They have ergonomically something that is pleasing to the user, like a ring. You know, you don't want a big square ring, because that would be nasty. Or a watch, or glasses, or whatever, and the ergonomics are such that actually finding a place for the antenna and doing that well is quite difficult to do. As this is the wireless charging forum, I don't expect to have to tell you this, but obviously we've talked about a number of these things already. Wireless charging is good to reduce contact failures, and I've got a pair of wired earbuds with pogo pins, and I have to clean the pogo pins sometimes because, yeah, I have very waxy ears. And that's a problem. Dirt and corrosion, waterproof enclosures. If you've got a smartphone or a smartwatch, or my watch will go down to 30 meters. You don't want to have, a lot of places where you can get water in. Wireless charging helps with that. The other thing is, if you've got a ring, how do you put a USB-C connector on a ring? date. Yeah. Obviously, that means you can reduce device size, and hopefully, this is the nirvana, I guess, unify the charging stations so you can charge your ring from your mobile phone, for instance. There are other technologies in the space, and one of the other ones that is used a lot is Qi. Qi is a very good standard, starts at about 3 watts and goes upwards. Renesa's telling us they can go up to 60 watts and further than that in the pipeline. What they do with that is they have to standardize the antennas. And so if you take your mobile phone apart, they have a standard antenna, and they specify several standard antennas. That's the way that they guarantee very high efficiency. Unfortunately, no Qi antenna will fit in a smartwatch, or even, and especially not a smart ring. It's fairly low frequency, so it uses inductive, so it's basically an air-core transformer, with a fairly high coupling factor, 50%. Yeah. These are the different kinds of devices that you see, and probably some of you own. NFC charging is slightly different, and we're aiming for a different market. We're not trying to compete with Qi, and we believe Qi and NFC will be in both devices, or on all devices together in some cases. It is standardized, and that's very important for mass market introduction. And as a semiconductor company, I mentioned earlier, we have to sell a lot of chips, so having a standardized solution does help with that. We are less than or equal to 1 watt, very small antennas, normally PCB based, so you don't actually pay for anything for the antenna, it's actually on the PCB itself. Very small thickness. In fact, you can't have a very thick antenna because of the way that, because of the high frequency, you're only working in the skin of the conductor anyway, so you have skin effect. So it's resonant inductive as opposed to just plain inductive. We're looking at 10% coupling factor or greater. They are very low coupling factors, in fact, compared with Qi. The other thing is that we do have this 106 kilobits data channel, and actually Pantronics were one of we do have proprietary extensions to the NFC forum, because the way the packetization works on NFC, you get from 106 kilobits, you get more like 20 kilobits of actual throughput. And so we've added new commands to the extension commands to the NFC forum, so we can get roughly 50% real bandwidth out of that 106 kilobits. Efficiency, very interesting. Again, Qi is quite good, 70%. We're looking at, today, some of our competitors are at about 30%, honestly. We're at about 40%, and we've got a roadmap and some ideas and some patents that will get us to 50% on this. Getting above that is more difficult because there's quite a lot of power in the background. When you're charging at 100 watts, 1 watt of overhead is 1%. When you're charging at 1 watt, 100 milliwatts of overhead is 10%. And it's the overhead that kills you in the end. For very low power applications, you have to get the overhead down, the transmitter power, how to make the power, the microcontrollers on there, even the memory that you're running the microcontrollers from are a few milliamps. And a few milliamps when you're transmitting 10 milliamps is a lot of percents. So that's what we're up against with the low power systems. And I mentioned this morning, these are 4 of the applications we're actively working on at the moment.
So the benefits of NFC charging, we still have the interoperability as per Qi, but we have bespoke antenna sizes. So that doesn't mean everything is interoperable at the physical level, because if you've got a huge antenna on one side and a tiny antenna on the other side, then your coupling factor will be terrible because it's area for area. Yeah? So providing you've got compatible antennas, there is compatibility. I won't mention it there. So, as I mentioned, we're talking with a few lead customers at the moment. We have a smart ring customer who is in advanced development, and they're looking at about 120 milliwatts of charging power in a smart ring, and it really does look like that. It looks a bit like my wedding ring, except black. They do all sorts of strange sensors things. It's amazing technology, actually. It's amazing they can get all of that stuff in small space. Stylus is a very easy sweet spot for us, and I showed you a mouse. If we can power a mouse, we can definitely power a stylus. The problem with the stylus is where do you put the antenna? Because they're very thin and they're very long. So getting enough antenna area from that kind of footprint is quite difficult. But it's possible. Smart glasses, we've got a very large customer who you would know talking to us about smart glasses. We're doing some prototyping with them, and they're doing some really interesting thing with this smart glasses. I can't tell you, but it's going to be great. Certainly for me, who's an English speaker and living in Europe, it would be great. Smart bands, watches, that kind of things. Also, interesting here, we are pushing the 1 watt. Smart glasses could go above 1 watt, except for, as I mentioned, the energy dissipation. So the problem with all of this is if you're at 50% efficiency and you're at 1 watt charging, then you start with 2 watts to get 1 watt. So you've also got 1 watt of power, 1 watt of heat energy to get rid of. This is a typical prototype board that we send, a demonstration board that we have. You can see the antenna on the right. Just to give you a sort of scale, that's about 20 millimeters by 20 millimeters, that coil. 3-turn coil, as you can see. We make the PCB the way we do, where you can actually take off the coil and put your own coil on. That's the idea. You can break off the PCB and join onto that. So our chipset is the one in the middle, of course. This is our polar chip, this is our power chip. And so that's a typical application. There's a lot of stuff around it that really in the application is not needed because this is a demonstrator, and I'm sure you know. Oh, okay. We even play, because we're Panthronics, so we have the Panther logo. And this is how we put our demonstrators together. So what you're seeing here is actually a transmitter and a receiver being paired. And then we put diagnostics on both sides, and you can see the power being transferred from one side to the other. So this is a demonstration kit that we give to our customers so they can see what happens. And as you saw, we make these plastic things so you can change the distance and see how the power changes. I mentioned our new receiver chip. This is not my thumb. I did have one with my thumb on earlier, but apparently my thumb's not pretty enough. So they did it again. It's 1.7 by 1.7 millimeters, this device. 3 square millimeters. And as mentioned, it has the NFC receiving function, so it has an NFC receiver. load modulator for communication with polar, its own microcontroller in there, but it also has a lithium-ion charger in there. So if you've got a very simple application, you don't even need a microprocessor or a microcontroller to go with it. You can just plug it in, charge a battery with it. It's programmable for multiple size batteries, of course. You can program it to charge up to 250 milliamps, basically, of charge current, with selectable termination voltages, etc., etc. This was just the, this is also a video. This is just this microphone thing, mouse thing that we're showing. This is the inbuilt diagnostic tool that we have that's showing you what communication is going on and what power you're sending and receiving. And you can move it around on the mouse pad. There's no reason, by the way, you can't have a mouse pad with multiple antennas on it. That's also possible. And I think that's it.
We have time for a few questions. Does anyone have a question for Stephen? Go ahead, Yuji.
How would you optimize the coupling factor when the distance between transmitter and receiver changes? So because it drastically impact for the power transfer efficiencies.
Yes, that's a very good question. We can get we're going up between 0 millimeter or 1 millimeter and 10 millimeters, and typically, certainly if you want 1 watt, you're really restricted to 10 millimeters. You can go further, but it drops off as a 6 power law, as you probably know, so it gets small very quickly. Because it's a resonance system, what you do is you actually match the components so that it goes into resonance at the sweet spot, where you want it to be. Yeah.
So you don't have the certain adaptive system that changes of the distance and the feedback system and to make it more efficient at each distance, or just fix the number that you're aiming at certain distance, like 35
That's a good question. There are facilities on our chip for resonance tuning. We haven't used them in anger yet with any customers. Our customers haven't had an application where they want to charge over different distances or tune the charging depending on where it is. Normally, if you say, okay, there's 5 millimeters between the two antennas, typical smartwatch, you've got bits of metal, bits of plastic between the two antennas, and you say you want 5 millimeters, normally we'll tune for that 5 millimeters and we'll get 100% of that 5 millimeters. But one of the things we do is we have robotics that actually do move things around in the space, because we have to have that for MVCO, which is a credit card thing. And so we move it around the space. What we find is you can get 90% of the charge at 3 millimeters and 7 millimeters. If you tune for 5 millimeters, you can get a good volume. Yeah? A good volume. So it doesn't have to be that precise. So you don't have to do it to, a few microns. It's millimeters, not micrometers. Yeah.
Thank you very much.
Thank you so much. I'm interested in, for normal communication applications, we're using HF RFID and NFC, a lot of coil modules, coil chip solutions to have the coil directly on the chip or in the package, and then use some booster antenna technologies to do the trick, and put in some ferrite material to even operate them in that environments. Are you also doing these tricks or using these tricks for charging with your solutions?
In the smartwatch system, we are using ferrites already to get better directivity, if you like, of the magnetism. We've got 3D EM simulators that we use to help us design those, so that we get the maximum basically the maximum efficiency with that. But the chipset itself is well capable of 50% or more than 50% efficiency, but the antenna system is the weak link at the moment.
Yeah, that is why I'm asking. I wanted to know maybe there are some restrictions and not to use an additional inductive link because you have too much losses then, using such coil-on-chip or coil-on-module solutions in combination with booster antennas to extend the range a bit more. Yeah. Thank you.
Okay.
Is there any movement in NFC forum to increase the power, or is it possible to have an array of antennas on the receiver side to increase the power, receiving power?
There's nothing precluding having an array of antennas on the receiving side, not even from the NFC forum. One of the most interesting things we're getting involved with, and there's a lot of pull from the market, is for TWS, so one transmitter and multiple receivers. That's not standardized at the moment in the NFC forum, but things like earbuds and hearing aids, for instance, they normally come in twos. So being able to charge two things at once is a very, very important application for us, and we're working very hard on it. We believe we have a solution, but it's not in silicon yet on that. But there's no problem with having multiple receiver antennas. It becomes exponentially more difficult to match everything together because it is a resonant system. That's all. But it is possible.
Thank you so much, Dr. Elwood.
Okay.
We have a little gift for you.
Oh, thank you. Another one.
Absolutely. Why not, right?
Thank you. I hope I get it through customs.
Thank you so much. Next, before we break for lunch, we have Dr. Thomas Meyer from Unplugged. He has a PhD in physics and has studied at MIT, along with obtaining an executive MBA. In 2010, he relocated to Norway and worked as a professor and a senior researcher for Norse. He later got engaged in research-based entrepreneurship, innovation, and the monetization of technical IPR, launching Machine Prognostics, a company that was commercializing edge vibration sensors. In 2021, he assumed the role of CEO at Unplugged, a wireless power company that's focusing on underwater applications. And today he's going to discuss the application of wireless power 3,000 meters below the surface of the sea. So enjoy.
Hi, can you hear me, guys? Yeah? Thank you for this introduction. And this is a tight spot to be between now. No sound?
No sound. You can use the other mic.
All right, take the other microphone. Which one?
Yeah, I think left.
This one? All right. As I was saying, this is a very tight spot to be in, just before lunch on the last day of the conference. So I promise you to keep you very much entertained with a lot of videos and things to talk about. And we are going to move away from the microchip with 1.7 millimeter or 3 millimeter higher to something much bigger. We are going to talk about wireless charging application at 4,000 meters subsea. We're going to talk about wireless application under Earth, and also wireless application into oil and gas platforms. Right. And I have decided to take you through a journey which is divided into 3 chapters. And the chapter 1, well, we call it wireless charging 20,000 meters under the sea, in reference to Jules Verne. And, you know, the speaker this morning introduced this platform, and our company is developing this platform. So here, what you see here is a drone, it's a subsea drone, which is built by Saipem, which is placed into one of our charging platforms. And to give you an idea of the scale, right, this is one single primary side, which is one of the 10, which is not the English platform. Right. And before I go in deeper notes about this presentation, I want to give you an idea about the structure of our company. And is a mother company that develops all of the hardware, the software, all of the electronic bits. We have a daughter company called SubsUSD, which we take our electronics and put it into marine casing, something what you see over here. And then we have a sister company that we take this electric coupler and put them into a mechanical structure that can be living subsea. And what you can see here, the primary side that you see here, you can see one of them here, but there is also here, 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 here. So this charging station have a lot of different opportunities for you to charge different tools. This is a simple picture to give you an idea of the scale of what we're talking about. This is a charging station going to be deployed into the North Sea. And deploying such ROV, landing autonomously subsea, is a complicated task. You have nobody to steer the drone. So the drone has to have different steps of inertial recognition, sonar, acoustic emission, machine vision, to recognize your plane. So here you have the concept on the left-hand side, and on the right-hand side you have the reality. And as you can see, the drone is able to land and charge. One of the things that we do, which is beyond wireless power, is that when the drone is getting closer to the landing pad, our coupler are going to send a magnetic field, what you see here, that allows the drone to land at a millimeter accuracy on the pod, on the coupler. Then, on top of electric charging, we also have data transfer embedded into the coupler, which data transfer at 1 gigabit per second full duplex. So, the beauty of these systems is not only that they are lying permanently at the sea, is that they are fully standardized. They are standardized mechanically, standardized electrically, standardized in the network infrastructure as well. It means that any drone following that standard can land and charge. This is a drone from Saipem. It's the same structure. This is a drone from SAP, this is a drone from Oceaneering. All of them use the exact same platform to land. And this is the company that are following that standard. And you will find some big names here. Chevron, Equinor, Lundin, Saipem, Siemens, Total. All of them use this standard. Meaning that if you want to penetrate that market and not following that standard, it's going to be very difficult. So this is a slide which gives you a summary of the different steps that is required for a drone on AUV to land autonomously subsea. And this is a recap of the specs of one for this primary site. They have 2.5 kilowatt power. They can lead 3,600 meters subsea, they're rated. Today we're working for 6,000 meter application. They have a 15 years lifetime. Mean time to failure is 15 years, meaning that they can live much longer subsea. They have 1 gigabit per second subsea comms included into the system, and they have magnetic homing. The two last bit is something I want to tell you a bit more about. In our coupler, we have some antennas, which is about 1 centimeter diameter. They are allowing 1 gigabit full duplex. But what is interesting with the network perspective is that they are fully transparent. The network administrator will not see any network modification into his map. This is what we call a wireless cable flags. Then I want to talk to you about the magnetic homing, because this is an add-on to wireless power. And what you see here is our coupler. They emit a magnetic field when they sense the drone coming over to help them to position. The magnetic field goes up to 1 meter into the air, a tiny bit less into the water, and there is nothing better than a video to show you how this works. So this is into the lab, and what you're going to see is a primary site, which is located here, a 2.5 primary site. And here you can see a secondary site with three magnetic sensors onto the mounted on it, and we just told the drone, which is this system at the moment, to land. So the drone is doing a triangulation of the magnetic field. So he's trying to balance the magnetic field to find the center. When you find the sender, well, it's just simply going to land. And when it's landing, you're going to see onto this pie chart here, the voltage of the secondary side, and the power coming out. So when it's already reaching about, I would say 20 centimeter, you can see a tiny bit of voltage coming out, and then he's happy, he has perfect alignment, he's able to land. Landing with a good accuracy is very important subsea, because there is mechanism that clamps the drone after to avoid any movement due to current and things like this. Now the system is fully landed and you have full power, 2.5 kilowatts, as well as data communication. So this is closing my chapter onto the subsea world, where it's into the subsea world. We are now going to take another book of Jules Verne, and then we're going to take a little journey at the center of the Earth. For most of you, drilling operation is something that you don't know where about. But it's often you have a drilling system on top side here, and you have a pipe which is between 3 kilometer to 12 kilometers these days, and then you drill for oil and you try to find something. What people don't realize is at the end of that pipe, which is 12 kilometers long, there is a ton of sensors. Pressure, temperature, and all of these parameters are measured. But as the pipe is rotating, it's quite difficult to get this sensor data out. So we got contacted by a company which is deploying such a system onto platform. And I present you here Johan Sverdrup, which is one of the third largest platform in Norway. They are huge systems. And when you drill for oil, as I was telling you, you have a very, very long pipe, which is located at the bottom of the top drive, what you can see here, and all the data coming out from this pipe. And they have problems to get out the data from here because it's rotating. So we've been given the task to develop an inductive slip ring to get out this data, which has a very long lifetime. Stopping an operation into a oil and gas platform is extremely expensive. So long lifetime was a very important parameter here. This is what we came up with. This is an inductive slip ring, which is mounted exactly here. And it's a 48 watt inductive slip ring. It's EX approved because most of the stuff we do are into EX environment. It has 17 input-output channels, 5 digital and 12 analog, and it has been running for 9 years without any interruption. Since we are talking about drilling operation, we have developed several other inductive slip rings. Here you can see a robot where we have created slip rings for the robot to be able to pick up and change tools, or into a hot environment, so hot picking up of tools into an EX environment as well, so no sparks allowed. And this robot is a robot which is specialized to take different tools, mount the pipes, give it to another systems, and so on, so he can go back and take another tools if he needs to. All of that, as I said, into an EX environment path. And here you can see a real picture of the robot, and you can see the inductive slip rings, which allow a 360-degree rotation, picking up different tools, and you can see the hands. This is 110 watt slip ring with 10 megabit per second communication. And for the last chapter, I'm going to show you what we do into a floating city, typically what kind of powered solutions we have into oil and gas platforms. We do charging station for robots which happen to live into oil and gas platforms. We cannot tell you too much about it. There is charging station topside into the X environment today. And then we go to that case. And they told us, can you help us into this specific case? What you see in this picture are a wellhead. A wellhead, and there is many of them. A wellhead is where the oil, the crude oil come out. It looks a bit like that. And what comes out of that pipe is oil, but also a lot of water, rocks, salt, and anything else in between. And what they want to do in that specific case is to measure directly with a sensor the pressure and temperature inside such a pipe. Meaning that it's impossible to put a naked PCB into this to be destroying a second. So the only solution for us that we could potentially measure the pressure and temperature into this was to put the sensor into a metal casing, meaning powering the sensor through metal. And this is what we did. What you can see here, and we also have in exhibition, you can see a system with a plate of metal 1 centimeter thick, and we are able to power up to 10 watts through metal, as well as establishing connection to such a sensor with a speed of 500 bits per second. I'm going to replay the video. Yeah, you can see we have just put a diode in this exhibition, but there is just nothing there. It's going through metal. I hope you have enjoyed this little presentation, and I'm going to leave you with the last quotation from Jules Verne. Anything one man can imagine, other man can make it real. Send us your problem. If we can fix it, we will do it for you. Thank you very much.
Thanks so much. We have time for a few questions. That was a great presentation. Anybody have a question for Thomas?
Hi, Thomas. Question is like, which other application do you think your technology can work with or will be relevant?
Well, so today, this kind of system, you can imagine that here we are very much project related. Very difficult project, very difficult environmental potential. But what we are doing now in this company is that we are democratization of the subsea world. We see that there is going to be this drone. There you are. These drones are special because they can do intervention. But in many cases, you don't want to do intervention. You want just simply to do a monitoring of the situation. So then you don't need such massive drones. So we see that there is going to be smaller and smaller fleets of drones living subsea permanently. And we are going to see maybe an explosion of maybe 100 times the size of the market of robotic subsea. In swimming pool, for example, when you watch the swimming pool, the robot could live at the bottom of the swimming pool, using wireless charging as a power source. So what we're doing now is that we're creating such a system for very cost-effective solution sets. That's one of the paths we have to do today. Charging e-boats. You know, everybody wanted a Tesla at some point or some electric vehicles. The next revolution will be e-boats. And then we have all the technology in the world to be able to make a docking station for e-boats really.
Thank you.
Any other questions?
What charging efficiency do you manage?
95% plus. So basically, we are using something around the 100 kilohertz transmission of power. If you try to do something higher in water, you will start to have some serious problem with losses. Underwater, most of the time you don't care about the air gap or the water gap. You want to be close contact. And close contact, if you want to have a high efficiency, this is the kind of frequency you want to use. What you care about is subsea, especially in such application. I mean, you have to appreciate the scale of what we're talking about. That you have wires that sometimes power an enormous field, meaning that you have 4 kilometer wire that make a lot of losses. So at the end of the line, you want to have an extremely high efficiency over the whole spectrum of power. These things, they are quite interesting because they will provide you with 93, 94% efficiency from 20% load up to 100% load. So it's basically power supply. And that's a specialty of them compared to other systems. I didn't want to go too much into the detail of technical into this. So
it was a point that I did not make. Efficiency is a multiplicative thing. Yeah? So if you start with 100%, the first thing takes 30, 70%, or you've got 70%, the second thing takes also 70%, now you're at 49. Yeah? And it's multiplicative. That's why efficiency is very hard.
Any other questions?
Yeah, I have one. So amazing presentation, by the way, thank you so much. I'm curious to understand What does the regulatory system look like under the sea, right? What requirements did you have?
Well, that's an interesting question. Nobody cares if you fire a fish. But there will be no fish down there because the drone makes so much noise that they will go away. But having said, it's a joke, these things need to be follow the regulation of topside because they are tested topside. So when you put them here, when they are here, sometimes they test them onto the platform. So we have to follow regulation that are laid out by topside. But Gary, maybe you can mention something about this. What kind of regulation you follow?
Yeah, we follow the normal EMC regulation. Yeah, we follow the normal EMC regulation, and that is regarding there's a lot of radio related to the research, which is a requirement that are quite strong on the radio bands, so we are following that, and also a lot of the other normal standard that we have to do for vibration, all those kinds of areas. So we are doing a lot of things that we have to qualify to get this to the platform.
There is quite a bit of detail into this standard suite, which is a very special standard. I mean, it's not G, not FIS, it's such a standard. It's something that you maybe don't know about it, but it's there.
Okay, so I have one question. Maybe I missed the frequency. Could you tell us the frequency? And then the other question is then, for the applications, do you have any optimal frequency in seawater?
Okay, company, they don't divulge too much things because I like to keep the public proprietary. But we can tell you that we operate around 100 kilohertz. Anything above that, you will encounter some problem with the water. Eddy current and all kind of stuff. You're going to make salt. So we are keeping in that range of 100 kilohertz, and then we manage to have efficiency around 93, 94, 95%. Yeah.
Vincent wants a question?
Great presentation. What is the maximum distance that you can pass with the magnetic field penetrations?
Okay, I think this video shows you a very interesting view of how far we can transmit power. This is into air. It's not quite the same thing, but you will see it there. Once the magnetic field is sensed by the sensor, you're going to see the voltage of the secondary side appear from here. The voltage and power, right? Then you're going to see that you're going to start to see some voltage appear from 20 centimeters of the wall. Just look at that. So he's happy, almost happy. It's not turned out yet. Okay. So he's going down. So they get a moment. You can see it in the video there. You start to see some voltage appearing. There is at least 20, 30 centimeters here, and you start to see some voltage. Of course, it's minimal, but then as you're going down, this is a close cooking technology. So if you can see that the voltage appearing. There is quite a big gap here.
What about the thickness of the conductor parts?
We are not too much interested in that.
Okay.
All right. Anyone else? Did we get all the questions? Excellent. Dinesh, did you want to take just a few minutes we have 5 more minutes before we break for lunch to talk a little bit about some of the emerging tech that you see coming out soon? For those of you who don't know Dinesh, he runs WPW, and he's an industry analyst, and I'd love for him to just take a few minutes and share what he sees coming in the market. He has a unique perspective, not making the product or advocating for a technology, but taking a look at all of us.
Thank you. Thanks for that. Very good afternoon, everyone. I will not take a lot of time here to the lunch break. But yes, as Chris mentioned, my name is Dinesh Pani. I'm the lead industry analyst covering the wireless power market. And this is the wireless power market. I keep a very close watch on different type of frequencies, different type of technologies, power levels, and around 30 applications from e-bikes, e-scooters to I would say mobile laptop, tablets, IoT sensors, infrastructure market, retail, electrician vehicles. Just to add a point about the trends here, I think the one big trend that I'm saying is happy to see is that at least some of the companies, many companies have started to move again, focusing on applications beyond mobile phones. Otherwise, we were stuck with mobile phones for a very, very long time. Everybody wants to be in their phones with their technology. Glad companies are looking to viral applications, be it variables, like I said, there's a list of applications. And because there are many different applications looked at, we are seeing not many different type of frequencies or technologies used. Low frequency induction, low frequency resonance. My presentation is there for you guys to check it. We have high frequency resonance, we have a natural standard also for that. NFC has come up with NFC charging technology, which is also showing some very good traction in the market for very focused small battery powered devices. And one of the other areas which are really growing very fast in terms of attention, pattern, popularity and all is distance charging. And distance charging could be in the form of RF, IR, infrared, ultrasound, microwave technology, and to add, energy harvesting is also picking up. Again, energy harvesting, some can still say that it's competing or complementing wireless power, but yes, that is also picking up as well. So that way it's good that things are picking up. The only thing which I'm saying, and I think Sanjay mentioned that point in the panel earlier, is that the problem is that many companies are developing the solutions and trying to find out a problem for that. Exactly. I think it's the other way around. We should develop solutions keeping the use cases in mind, the consumer pain points, and then develop wireless power solutions. Otherwise, we will just get stuck at the same time. And less companies are giving attention to the industry standard. For example, mobile phone had a very good industry standard, but we can see most of the market is using proprietary solutions there. I don't think there's a right way to go forward. But I guess in the next 2-3 years' time, there'll be a lot of fragmentation in the market, but again, we'll be back to consolidations into few frequencies looked at and all those things. And the last comment would be, individual devices currently have only one wireless power solutions, like low frequency, high frequency, or distance charging, anything. But maybe we'll see things like communication, maybe 5 years down the line, mobile will have one or two more solutions, not only say example low frequency induction, resonance or RF as well, or NFC there. So multiple frequency within each applications could also be one of the trends coming here. And like I mentioned in my reports, in the next, I would say around 7 years time, 8 years time, around 10 billion devices will have wireless power in terms of it, receive and transmit using different solutions. So this is a very big one from my side. So any questions, feel free to contact me. You'll have my number, name, picture. Any questions, please? Happy to answer a couple of questions if you have time. Sorry, I was a little faster, but yeah, at least I hope you know the point.
What is your view on the wireless charging of passenger vehicles at home?
Good question, interesting topic, hot topic I would say. I would say yes, I think for the last 3, 4, 5 years, companies, OEMs were evaluating that, the utility companies, infrastructure were evaluating that. I think this time has come, we have the SAE standard already finalized, maybe a little bit of tweaks here and there. And I'm again, without giving much information, I'm seeing OEMs adopting the technology as an additional feature of providing to consumers. So in case you are buying electric vehicle, it will already have the plugged-in charging, but the option will be given to consumers saying, yes, if you want, you will also have wireless charging, but there's a lot many benefits to that. I'm sure in the panel we also discuss, and the other panel we talk about that, the efficiency of EV charging. And I think people think that EV will have around 30, 40, 50% efficiency charges, but you'll be surprised to know efficiency is 90 plus and is nearly closer to what we will provide in the what I would say is with the wire charging. And just to on the point about the trends, I think this is what 2022. I think latest by 2024 there will be more cars which will be wireless charging. This is passenger cars, but we've already seen projects happening for taxis, buses, even ferries. There are a few companies doing electric ferries being charged wirelessly already in the market. So yes, I don't think that's a dream or fiction. It's just there, EV charging will happen. Maybe dynamic charging will take a lot of time, but static charging will be there, I would say. Hope that answers the question.
One more question for Dinesh? Anyone have anything? Okay. Well, thanks so much. for joining us this morning. We're going to break for lunch and we'll reconvene here at 1:30. Okay?
I go 2 weeks every 6 months. I just say sure, come on. Yes, I think that's.
We have a whole lab downstairs with robots. I'm sure you know about it. Yes, yeah, of course, yeah. Always, yeah, we have the contact person today, but I don't know, I used to be because of the end. Your influence is really important because they are also very like short-term focused. Right? So if there are challenges that they face, you can help them overcome. Or if it needs 6 months or a year to develop some technology for you, so you can help them, which I think will be very good for everyone. Right? Okay, very good. Well, then we can go get some lunch. Sure. Oh, it was awesome. Yeah, everything was awesome. Wednesday or Wednesday event that we had, right? It's been amazing. Every event has been very nicely done.
Just understand some demonstration this morning. I missed them. Yeah. But we from here and and J also. Distribute. Yeah. Research. Yeah. One guy also he studied something in Greek and but online just to fly for the lecture. And it's okay. I don't think it was for everything. It's still flying, but still it's cheap for you to live in another country and just travel for the subject. Yeah. They are very for doing good? Certificate? Oh, just was say my name is I can say then maybe you need it for I need also that questions because it all my career was part from the university. Maybe you were doing for 1 week in Florence. I can wait a week for you. I still was doing
عايزك تعرفوا سلام داشته کنم. نمی‌دونم چطور برای گفتم این با هم سری بگیم چند تا با بیشتر من نهار رفتم که بگیرم دیدی که شوری رفتم اینا کردیم ایضا من خیلی بیرون میشه این 166 دلار باید بگیرم همین 45 دلار دارم همین گفتم که بگیریم یک من این همه گفتم باز نکردیم ما شاید اون سفر باز نکردیم اردو بگیرم آره 518 111 یورو آره یه دونه بیشتر داره نمیدونم 6 یورو یه دونه نه یه دونه سیب بیشتر نداره دونه 166 هم دو تا سیب داره حساب بگیرش تمام میشه واسه نمیدونم 45 یورو من بهت فرستادم 45 یورو مثلا یه سیب متوجهی تمام شد اصلا آره سه تا مونده بود آره 5 یورو حساب اساس دادیش ایضا سه تا سشن آره من اساس دادیم هیچ ایضا خودتون می‌خواستم بیرون نشه دیگه من تو 7 12 9 6 تا 111 دلار بخواید بگید دیگه 7 12 9 11 16 دو تا 14 آره باید 45 رو می‌دوستیم بگیم من با 70 دلار گرفتم بازم 45 رو بگیم فرد چقدره بریم اردو کنم مسئله داشته باشیم
T'as une micro, Nicolas? Au besoin, oui. Je vais vous demander, je répète, parce que moi j'ai plus de tu veux que ouais. Parce qu'en fait, là, on est. Le texte de film a été coupé du coup. Non, il n'a pas été